Good morning.
Sir, okay, చిన్న అనౌన్స్మెంట్ చేయండి సార్.
Em.
అనానమస్ అటెండెన్స్ నేమ్ చేంజ్ చేసుకోమని చెప్పండి.
Okay.
అనానమస్ అటెండెన్స్ నేమ్ చేంజ్ చేసుకోమనండి. ఇఫ్ ఎట్ ఆల్ నేమ్ చేంజ్ చేసుకోకపోతే గ్రూప్ డిలీట్ చేస్తా అని చెప్పండి.
Okay. నేను స్టార్ట్ చేసి చెప్తాను. ఓకే, నో ప్రాబ్లం.
చెప్పండి ఇప్పుడు.
స్టార్ట్ చేసాను. ఓకే. Good morning, my dear students. So I'm going to start the subject communication systems. The basic concepts required for this subject, you know very well, some concepts from signals and systems required for some of the students. That subject may not be over. I am giving a clear idea about that subject, what is required for communication point of view, that I am going to explain, and then I am going to start the subject. First, I am giving a revision of signals and systems. Some of you might have attended my classes already, and there are new students also. So now the old student just listen the concepts and try to solve as many questions as possible. So one important point about this subject is that the some subjects like control systems, you will be in a position to understand the concepts very easily, and much practice also not required. But communication subject, it requires a lot of concepts of other subjects, and also more practice is required, then only you will get the confidence. So the some subjects like communication, EMTL, signals and systems, you have to practice as many questions as possible, then only you will get the confidence in this subject. So in that aspect, what are the textbooks you have to practice, and that I'm going to explain. First of all, the GATE or engineering services examination point of view, always I prefer communication systems engineering by John Prokis. Communication systems engineering. There are various textbooks on this subject. The point is that for the GATE or engineering services examination, what type of questions being asked in the examination? Mainly for the prelims of engineering services as well as GATE, what is required is 1 mark and 2 marks questions. In that aspect, the textbook Process is very much useful. Many questions given in the competitive exams are from this book only. Especially the exercise problems given in this textbook are in that fashion. You will find 1 mark and 2 marks, which are very much useful for the GATE exam. If you practice those questions, most of the models will be covered, and you will get a clear knowledge about this subject is concerned. Majorly in this subject, the very important topic is about the noise analysis as well as probability of error calculations. If you gain the confidence in those two topics, the remaining topics are very simple. In that aspect, this is a very useful textbook, Communication Systems Engineering by Prokis. And other textbook always I prefer is Analog and Digital Communications. SAM series. So these are the two books basically you have to follow for this subject. in my opinion, 90% of the syllabus will be covered if you go through these two textbooks. Any additional topic, textbook required that I'm going to discuss while discussing the particular topic is concerned. Basically, these are the two textbooks you have to follow. Okay. Now, at the end of the session, only I am attending the doubts. So, first listen, you type, or at the end, the class is 8 to 1 p.m. In between, we'll have a break for 20 minutes, and then again I will resume, and at 1 p.m. you can ask the doubts or concerned. So you write in the, already you have attended other classes, so here you will find 1F, 2F. Just write the page number. Whenever you are asking the doubt, just tell me that page number. I'm writing continuously here, 1F, 2F, 3F, like that. Here you can observe. So there you can write the page number in which page you are having the doubt, so that I can it is easy for me to the topic what you are asking is. And some students have joined this Zoom session with anonymous, without any name, with anonymous member. So please change that anonymous to your name, otherwise you will be deleted from the session. So please, those who are joined this meeting with anonymous without any name, please change that status to change the name, so then only will be allowed to for this session, otherwise you will be removed from this session. Okay. Now, the point is, each and every day's session, go through clearly. Whenever I'm explaining, you will be in a position to understand. But once again, go through the session, and better to ask doubts in the next class. Whatever I'm teaching today's class, better you go through once, ask in the next class. If possible, try to download these two textbooks. They are available in the internet. You can easily download. Otherwise, I will tell you from where you can download these two books also. Now, the subject point of view, you know very well, it is very difficult to imagine the present day without communication. We can't live without a communication system. So now it become part of our life. Now the point is, what is the major objective of any communication system? So I want to transmit information from one place to another place. That is the main objective of any communication system is considered. Now, what is the type of information we are transmitting from one place to another place? That is more important. And some of the textbooks, you will find the title electronic communication. The meaning is that I want to transfer information from one place to another place using electrical signals. With the help of electrical signal, how to transfer the information. That is why some textbooks you'll find the title electronic communication systems. Now, what type of information we are transmitting from one place to another place? It depends on the application. In telephone, what we are transmitting is the voice signal. And what are the other signals we are generally transmitting? Are voice, audio, video, and binary data. So these are the four different types of signals we are always talking in this subject, but there are many other signals also. But what are those other signals we are transmitting in the applications? I'm going to explain. One thing is that each and every subject, whenever we are talking, we are concentrating on certain parameters. For example, control systems. In the subject control systems, always we are talking about the stability. The reason is, if the system is stable, then only you can call it as a control system. or it is possible to control the output of the system. If the system is unstable, you cannot call it as a control system. So always we are talking about stability in the subject control systems. In communication, always we are talking about the frequencies. Why we are talking about frequencies? In the design of any communication system, what is the precaution that we have to take? We have to see that there is no interference from one signal to another signal. So always we are talking the terminology interference. When the interference occurs between two signals is only if the frequencies are same. If the frequency of the first signal and the frequency of the second signal both are same, then only interference occurs. So in this subject, always we are talking about the frequencies. Now, you know very well voice. What are the frequencies of a voice signal are in the range of 300 to 3.5 kilohertz. One application where we are transmitting voice signals alone is in telephone systems. This is one example where we are transmitting voice signal. Next is audio. You know very well, audio frequency range is 20 hertz to 20 kilohertz. One very important clarification. What is the difference between voice and audio? Please carefully think about it. Voice means only human voice. Audio, see the name. Any sound that we are able to hear, you can call it as the audio signal. For example, take a musical instrument. That sound we are able to hear, but it is not a voice signal. So remember, audio means any sound that we are able to hear is called as the audio signal. Voice is also a audio signal, but in telephone, I want to transmit only the voice signal. And where we are transmitting audio signals is a simple example I'm giving is radio. So whenever you are listening to radio, it includes voice as well as music or any other sound. So remember, audio means it includes voice, music or any sound that you are able to hear. Sometimes voice or speech. Then video is having frequencies from 0 to 4.5 megahertz. This value will change. The latter I will tell you based on the application. For the time being, take it as 0 to 4.5 megahertz. Now, binary data. One way of representing the binary data practically is in the form of rectangular pulses. What are the frequencies present in a binary data? They completely depends on the pulse width. Please remember this rectangular pulse is there, whether the pulse width is 1 millisecond or 1 microsecond. So frequencies present in a binary data, they depends on the pulse width. This I am going to explain in a detailed manner. A simple application where we are transmitting the binary data is internet. Internet, always you can call it as a data communication system. From one computer to another computer, what you are transmitting is nothing but binary data. So in the entire subject, always I'm talking about the transmission of these four different types of signals. How to transmit a voice signal, how to transmit the audio, video, and binary data. Now, I told you the page numbers. Now it is 1F, 2F. Next I'm moving to 3F. So if you are having any doubt, just note down that page number. Some students are raising the hand. I'm not attending the doubts immediately. I will attend the doubts at 1 p.m. Once the session is over, theoretical session, then only I will be talking about the okay. Some students asking about the weightage of this subject in the GATE examination. Except instrumentation, ECE students, this is the core subject. Our course, electronic students, electronics and communication. So this is the main subject for ECE students. Generally, the weightage always will be from 10 to 15 marks in the GATE examination. So please remember 10 to 15 exam. The in the engineering services, it will be around 25 marks. It will be 20 to 25 marks in the prelims exam. So very, very important for both GATE as well as engineering services examination. For GATE exam, most of the questions given will be only numerical type questions. You will not find any theoretical questions. Uh, in the engineering services exam, calculator is not allowed. So that is why most of the questions given in the engineering services prelims are from basically theoretical type of question. That is a major difference in this subject. So engineering services prelims, you can expect only theoretical and very simple calculations are involved, those type of questions. Whereas for GATE exam, purely numerical type question. And I forgotten the instrumentation students also present in this session. For them, total syllabus is not there. Uh, Only analog communication complete syllabus is there for instrumentation students. Digital communication also only some limited portion. Noise and probability of error not there for uh, instrumentation students. So at that time, the I will inform whenever the syllabus is not there. If you are instrumentation students, if you are writing only the GATE exam, then no problem. But many of the instrumentation students are writing other competitive exams like ISRO or any other public sector exam. For that, total subject is required. So it is my sincere advice to attend the total classes. But if you are writing only GATE exam, entire unlock communication and only some part of the digital communication is required for the instrumentation students. Noise and probability of error, information theory concepts not at all required for the uh, instrumentation students. For GATE as well as engineering services, the syllabus is almost same except two or three topics. I will mention those topics which are additional for the engineering services students' point of view. So, sorry for the deviation, because some students asked about that weightage of the marks. Already I told you about the textbooks. Now I have given you about the weightage. Some students raising the hand. I told you I will attend them only at the end of the session at 1 p.m. Okay. I gave the introduction. In the entire subject, we are talking about the transmission of these four different types of signals: voice, audio, video, and binary data. Now, I want to explain the block diagram of a communication system. Now, I'm giving you the generalized block diagram. Listen carefully. I want to give the generalized block diagram. Why I'm using the word generalized block diagram? The Block diagram of a communication system depends on the application. For example, what is the block diagram of a radio? What is the block diagram of a TV, radar, satellite, mobile phone? So the block diagram of a communication system depends on the application. Now, I want to explain the generalized block diagram, and what is the application I'm taking is I want to transmit a voice signal from one place to another place. Now look at this block diagram. Just wait for 2 minutes. I told you I'm explaining the generalized block diagram which is applicable to all cases. What is the example I'm taking is voice transmission. Voice means one application you can think is a telephone or a mobile phone. So whenever you are talking on a mobile phone, we are transmitting the voice signal from one place to another place. Now, carefully think about. In the introduction, I told you electronic communication. That means I want to transmit the signal from one place to another place using electrical signals. But if you see, voice is not an electrical signal. So first we have to convert this non-electrical quantity into electrical quantity. You know very well that we are calling the transducer. Transducer will convert from one form to another form. Here my requirement is to transmit voice signal into electrical signal. What is the transducer? Used is a microphone. Microphone converts voice signals into electrical signals. Signal means it is a function of time, and what is the parameter that changes with respect to time is nothing but a voltage or current variation. Listen carefully. Voltage or current variation along x-axis is a function of time. Now, one thing, if you observe, what is the shape of the curve I indicated? Completely, it is a random signal. Reason, most of the practical signals are random signals. They are not deterministic signals. The deterministic means like a sinusoidal, exponential, ramp, or unit step. The why it is called as the random signal means the voltage or current is changing randomly with respect to time. So except for instrumentation, for ECE students, it is one very, very important topic, random signal theory, that we are going to discuss in a detailed manner. So it is a very, very important topic uh, for communications subject. So we are converting non-electrical quantity into electrical quantity unless otherwise given in the question. Always we are assuming that it is a voltage variation. Again and again I'm saying the voltage is changing randomly with respect to time. That is why it is called as a random signal. Now listen, whatever be the communication system, whether it is a radio, TV, mobile phone, radar, satellite, whatever be the system, always at the transmitter side you will find modulator. So major portion of the syllabus is about various modulation and demodulation techniques in both analog as well as digital communication systems. So why this modulator is required and what is the concept of this modulation, I'm going to explain in a detailed manner. So remember, first, for the time being, any communication system at the transmitter modulator is required, and this modulator will modify the signal according to the transmission characteristics, or we are modifying the signal suitable for transmission from one place to another place. The output of the modulator is also an electrical signal. Now that electrical signal is transferred from one place to another place by using a communication channel, or sometimes called as a transmission media. Communication channel or transmission media. What are the various types of communication channels that are used? Or simplest one is nothing but the twisted pair. Twisted pair. Second one is coaxial cable. Third one, fiber optic cable. And the most important one is the free space. Whenever the channel is the free space, we are calling it as wireless communication system. So the channel in this case is nothing but the free space. With the help of antennas, we are transmitting the signal from one place to another place. So first three, where I'm calling it as wire communication systems. Now leave about this free space. Later I will discuss. Uh, Take the first three cases. First three means twisted pair, coaxial cable, and fiber optic cable. Whenever we are transmitting the signal from one place to another place, due to various losses in the channel. Whenever you transmit the signal, there will be so many losses associated with that cable. If you have studied fiber optic communication as a subject, you might have studied there are various losses in a fiber, like absorption losses, scattering losses, bending losses. So due to various losses, signal strength gradually decreases. What is the signal strength after 1 kilometer, after 10 kilometers, after 20 kilometers? So signal strength gradually decreases. So along the communication channel, we have to place repeaters. Listen here, just I'm writing R. R represents the repeater. So in analog communication systems, repeater is nothing but a amplifier. But in digital communication systems, repeater is not a amplifier. Later I will explain. There in digital communication systems, it is called as regenerative repeater. Why it is called as regenerative repeater and how it works? Later only I'm going to explain. First thing is that how many repeaters are required? Carefully think about it. How many repeaters are required in a communication system? It depends upon the distance between the transmitter and receiver. Listen carefully. The how many repeaters are required in a communication system? First thing is that it depends upon the distance. Suppose if the distance is more, it requires more number of repeaters. Second one is it depends upon the type of the cable, especially engineering services students. You will find theoretical questions. Please be careful. Type of the cable. If a fiber optic cable is used, the losses will be very, very less. So whenever a fiber optic cable is used as the link or a communication channel, requires less number of repeaters. The reason I'm saying is the losses are very, very less when compared with twisted pair or coaxial cable. So it depends upon the distance, type of the cable. Third point is it depends upon the transmitted power also. Remember, it depends upon the transmitted power. Suppose if the transmitted power is more, then also less number of repeaters are required. Fourth point, the number of repeaters, it also depends upon the type of modulation technique. How it depends upon the type of modulation, you will be in a position to understand later that I'm going to explain. So remember these 4 points. Whenever it is asked in the interview, the number of repeaters depends on the distance, depends on the type of the cable. Third one is transmitted power or sometimes signal to noise ratio. That we'll discuss later, signal to noise ratio. Fourth one is type of modulation technique. I told you how it depends upon the type of modulation that I'm going to discuss in a detailed manner. Now, at the receiver side, always required is the demodulator. At the transmitter side, modulator, and at the receiver side, demodulator. What is this modulator and demodulator that I'm going to explain in a detailed manner. Then finally, transducer is also required. I told you my objective is to transmit a voice signal from one place to another place like a telephone. We are talking on a telephone. In a telephone, my objective is to transmit a voice signal. At the receiver side, once again, you have to convert that electrical signal back into voice. So transducer is required. So what is the transducer used is the loudspeaker or speaker. Loudspeaker converts electrical signals back into voice. So I'm saying that this is the generalized block diagram in which I have explained you how to transmit a voice signal from one place to another place. Example I told you is a telephone transmission. Now listen carefully. Suppose if you take a radio and TV, radio and TV both will act as a receiver. So it is only a receiver. Suppose if you take a mobile phone consists of both transmitter as well as receiver. Whenever we are talking on a mobile phone, we are transmitting as well as receiving. So in a mobile phone, both modulator as well as demodulator are required. The combination of modulator plus demodulator, it is called as modem. Modem means modulator plus demodulator. You might have known this word. modem, modulator plus demodulator. Now, sometimes communication systems are classified like this: simplex and duplex systems. A simplex system is a one which is capable of only transmitting or receiving. So remember, it is capable of only transmitting or receiving. A simple example of a simplex system is radio and TV. In a radio, just we are listening, we are not able to transmit anything. So it is called as a simplex system. So simplex systems are capable of only either transmitting mode or in receiving mode. Sometimes we are talking about duplex. In duplex, again, two types: half duplex and full duplex. Okay, what is the difference between half duplex and full duplex? Duplex, first thing is that duplex system is capable of both transmitting as well as receiving. I told you simplex system will be only one mode, that's all. Like a radio, radio means it will be only receiving, that's all. So either transmitting or receiving. But in a duplex system is capable of both transmitting as well as receiving. But what is the difference between half duplex? In half duplex, the system will be either in only transmitting mode or receiving mode. So at a time, it cannot do both operations. So we'll be in a position to transmit as well as receiving mode only. A simple example of half duplex system, most of you might have seen, police people will be carrying a wireless set. If you observe, it will be always receiving. Whenever a police people wants to talk, they will press a button, transmitting mode, and then will be transmitting. Whenever in transmitting mode, they will not be in a position to receive. Again, if you press the button receive, they will be receiving. So in half duplex, that handset is capable of receiving as well as transmitting, but at a time only one operation, either transmitting mode or in receiving mode. But full duplex system is one simultaneously we can transmit as well as receive. So what I'm saying that in half duplex we will be transmitting mode or only in receiving mode, at a time only one. But in full duplex, we are transmitting as well as receiving both at the same time. Simple example of a full duplex system is a mobile phone. I told that full duplex. Simplex system, I told you the example is radio and TV. Just they are only receiving, that's all. But duplex system, half duplex means only either transmitting or receiving at a time. Example I told is police people will be carrying a wireless set. Just if you observe that one, they will be only receiving mode or transmitting mode. And a full duplex one is one which is capable of transmitting, both transmitting as well as receiving at the same time. Example I told is a mobile phone. Okay, I'm moving to now page number 5F. That is what I told you. If you are having any doubt, just write page number. Finally, at the end of the session only, I will be attending your doubts. Just write that number. Some of the students are raising the hand, but I'm attending at the end only. Now, I explained you the block diagram of a communication system. First point I want to explain here is why this modulator and demodulator are required in a communication system. What will happen when this modulator and demodulator is not present? So very, very important. The core idea about the subject we are going to get only from this. First, I want to explain why modulation is required. I am putting the heading need for modulation. Very, very important. I told you like control systems. Always we are talking about stability because if the system is stable, then only we can control the output of the system. Then you are studying what is meant by stability. Like I am talking about need for modulation or why modulation is required. Carefully try to understand this concept. Again, I am taking the example voice transmission. Okay, this is a microphone which will convert voice signals into electrical signals. First, I want to explain what will happen if the modulator is not present and how that problem is eliminated by using a modulator. I told you the example I'm taking is a microphone. Try to understand the basic concepts carefully. I told that some students might have attended already my classes or any other institute. Just take a revision and you have to practice more number of questions and try to ask those doubts. Okay, now look here. Microphone converts voice signals into electrical signals. Now look here. Now assume that the channel is a free space. Listen, there are various reasons to go for modulation. First, I want to take the example of a wireless communication system. Whenever you talk about wireless, antenna is required at the transmitting as well as receiving side. First, I'm explaining what is the problem when the modulator is not present. Now see carefully. In the subject EC students, antennas and wave propagation, you might have studied about various types of antennas. The physical dimensions of any antenna, I'm using the word physical dimensions of the antenna, or some textbooks you'll find size of any antenna depends on the parameter wavelength lambda. Example, you might have seen half wave dipole, quarter wave dipole, or all of us might have seen the uh, antenna, parabolic antenna or dish antenna. What is the diameter of a parabolic antenna? So what I'm saying is that the size or physical dimensions, what is the length of a dipole antenna, like that, physical dimensions of any antenna will be expressed in terms of lambda, sometimes lambda by 2, lambda by 4, lambda by 10. It depends on the application. You know the fundamental formula for lambda. Lambda is equal to C by F. Three into 10 to the power 8 meters per second. Voice means what is the minimum frequency we are transmitting is 300. So if you simplify, what is the answer for wavelength I'm getting is 1000 kilometers. Listen carefully. See that value 1000 kilometers. Suppose if you take size of the antenna like a length of a dipole lambda by 10 you take. Even if you take lambda by 10, what is the answer you are getting is 100 kilometers. My dear students, carefully think about this point. Size of the antenna is 100 kilometers. Is it possible to imagine size of the antenna in the order of 100 kilometers? So it is impossible to imagine the size in the order of several hundreds of kilometers. So how to reduce the size of the antenna? Remember, size of the antenna always depends on lambda. How it depends on lambda? Later, please ask your EMTL lecture. There you will be in a position to explain, because a lot of EMTL concepts are required, how the size is related to lambda. So that part I am not answering. The EMT classes, whenever EMT classes are going on, at that time clarify your doubt, what is the relation between size of the antenna and the wavelength. Now see here, the important point is, now what is the point that you have to observe? It is impossible, listen carefully what I'm saying, it is impossible to transmit a signal which is having significant low frequency components. Voice means, what is the minimum frequency? 300. I got 1000 kilometers. Suppose if you take a audio, what is the minimum frequency? You know very well, minimum frequency is 20 hertz. Just substitute, even that value will be even very high. Video, what is the minimum frequency? 0. Again and again I'm saying, it is impossible to transmit voice, audio or video signals directly into free space. The reason I'm saying is lambda answer 1000 kilometers, or size of the antenna depends on lambda. Now, how to reduce the size of the antenna? So you have to reduce lambda. How to reduce lambda? The only option available is by increasing the frequency. Now carefully observe. So how to overcome this problem? What is the problem? Again and again I'm saying, problem is I am not in a position to transmit the signal directly into free space. The reason I'm telling is, size of the antenna I'm getting in the order of several hundreds of kilometers. How to overcome this problem is by modulation. Carefully think about this, because complete subject is about various modulation techniques. So what is the role of a modulator? Very basic definition I'm giving. I'm going to discuss in a detailed manner what are the various definitions of modulation. Now listen carefully. The simplest definition of modulator: modulator will convert a low frequency signal into a high frequency signal. Listen carefully. Modulator converts a low frequency signal into a high frequency signal. As the frequency increases, wavelength decreases and size of the antenna also decreases. So what I'm saying, that simplest way of defining modulator is, modulator role is to convert low frequency signal into high frequency. Again and again I'm saying, where we are transmitting voice signals into free space is a mobile phone. So take a mobile phone, we are transmitting our voice into free space. Microphone converts voice into electrical signals. Mobile phone means, you know very well, nowadays we are talking about 2G, 3G, 4G. Next we are talking about 5G. So what is the frequencies allocated? Later I will explain. Suppose if we take a 2G mobile phone. In the case of a 2G mobile phone, the frequencies starts from 800 megahertz. That means whenever you are talking on a 2G mobile phone, our voice is converted into 800 megahertz. Listen carefully. Our voice is converted into the range of 800. Now you calculate. Instead of 300, now you substitute 800 megahertz and simplify lambda. I told that size of the antenna lambda by 2, lambda by 4, lambda by 10. So if you calculate what is the value you are getting is almost a negligible quantity. So all of you are using a mobile phone. What is the size of the antenna in a mobile phone is almost a negligible quantity. So listen carefully how we are in a position to reduce the size of the antenna is with the help of modulator. We are in a position to convert a low frequency signal into high frequency. But how to convert that low frequency to high frequency, I'm going to explain in a detailed manner. For the time being, just remember modulator role is to convert low frequency signal into high frequency signal. As the frequency increases, lambda decreases and size of the antenna also decreases. Now, I want to give another example. What is the another example? Again, I'm taking a mobile phone only. In a mobile phone, voice is considered no problem. With the help of modulator, we are converting into high frequency. In some of the mobile phones, you are getting FM radio. So some of the mobile phones I'm saying. You may be knowing FM radio. What are the frequencies allocated for FM radio are in the range of 88 megahertz to 108 megahertz. These are the frequencies allocated for FM broadcasting. If you are listening to FM radio, check it out. Radio stations, all radio stations you will find in this range only. Now, same using the formula what I have explained, calculate at 100 megahertz. Now, what is the value you are getting is somewhat significant. Now the point, please kindly observe in a mobile phone, you are not getting FM radio directly. When you will get FM radio in a mobile phone is only whenever you are connecting the headphones. Listen carefully. Whenever you connect the headphones, then only you will be in a position to listen the FM radio because that headphones will act as the antenna. Please remember, any open wire will act as the antenna. Later, sir will be MTL faculty will be discussing about that concepts. So that headphones will act as the antenna, then only you will be in a position to receive the FM radio. There are so many wireless systems in a house, like a cordless phone or a Wi-Fi router you might have seen. You will find all antennas. So what is the size of the antenna depends upon the frequencies. So I'm saying that in the case of a 2G phone or 3G, 4G, size of the antenna is a negligible quantity. But FM radio, size of the antenna somewhat significant. So whenever you are using a FM radio in a mobile phone or standalone system, if you take, you have to use antenna, then only you will be in a position to receive the signal clearly. Now, so the first point, why the modulator is required is to reduce the size of the antenna. Please be careful. Some of the students, they are using the word height of the antenna. Height of the antenna is not the correct answer. Size or physical dimensions of the antenna. To reduce the size or physical dimensions of the antenna. Second point, why modulation is required in any communication system is for multiplexing of signals. You know very well What is meant by multiplexing? Multiplexing means I want to transmit more than one signal through the same communication channel. Now, one point I want to say here is, don't think that modulation is required only in wireless communications. It is required not only wireless, it is required even in wire communication also. For example, I have established a link wire communication from one city to another city. Like from Hyderabad to Mumbai, I established a wire communication system. Suppose if I transmit only one signal through that cable, in that case, we are not effectively utilizing that resource. So my objective is to transmit more than one signal through the same communication channel. That process I'm calling it as multiplexing. So multiplexing means transmission of more than one signal through the same communication channel. Look here. So I want to transmit more than one signal through the same communication channel. You know very well, basically two techniques: frequency division multiplexing and time division multiplexing. FDM, it is used in analog communications, whereas TDM is used in digital communication systems. One point now I want to say is that multiplexing possible only with modulation. Without modulation, multiplexing is not at all possible. That concepts will be clear to you in the topic FDM, frequency division multiplexing, that I'm going to discuss later. So what I want to say is that modulation possible only with multiplexing. Without modulation, multiplexing is not at all possible. That I'm going to explain in a detailed manner. Now the third point, why modulation is required in any communication system is to reduce the effect of noise. Noise is one major topic in the ECE syllabus. Already told you, instrumentation students, noise concepts are not required for the GATE exam. But if you are writing other competitive exams, it is required. So better you understand. Later I'm going to explain about noise analysis. So listen carefully. Whenever you transmit the signal through a communication channel, that signal is always affected by noise. How the noise will affect a signal, that I'm going to explain in a detailed manner. Whenever a signal is affected by noise, my objective is to determine what is the effect of noise on the signal. How to determine the effect of noise on the signal is by calculating the signal to noise ratio. Listen carefully. What is the condition for demodulation at the receiver side? Remember, what is the condition for demodulation? Always is signal to noise ratio should be very much greater than 1, then only the demodulation possible at the receiver side. Suppose if the signal to noise ratio is less than 1, carefully think what it indicates. Signal to noise ratio less than 1 means, what is the meaning is, noise power is greater than the signal power. Whenever the noise power is greater than the signal power, we are losing the information and demodulation not at all possible at the receiver side. So whatever be the communication system, whether it is analog or digital communication, what is the condition for demodulation? Condition for demodulation is always signal to noise ratio should be very much greater than 1, then only the demodulation possible at the receiver side. Now the point is signal to noise ratio again depends upon the type of modulation technique. What is the signal to noise ratio if AM is used? If FM is used, if PM is used. So signal to noise ratio always depends upon the type of modulation technique. So that we are going to discuss in a detailed manner about signal to noise ratio calculations. So you may be knowing in FM frequency modulation, the effect of noise will be very, very less. So the later will be discussing why the effect of noise is very, very less in frequency modulation. These are the three major points why we are going for modulation. All I told you, the entire subject is about various modulation and demodulation techniques. And first point I told is to reduce the size of the antenna. Second point I told is multiplexing. I told you more than one signal transmitted through the same communication channel. A simple example of multiplexing is cable TV. A cable operator is giving you some 100 TV channels. All 100 signals are transmitted through only one cable. What is the cable used in TV transmission is coaxial cable. All these concepts will be clear to you. Just it is an introduction. Just listen. Try to understand the terminology first. So later we'll be discussing in a detailed manner. Not only these three, there are some other points also why modulation is required, especially engineering services students. I told that for the prelims exam, you will find theoretical questions. In one of the exam, it is asked which of the following are the not the reasons for modulation, like that. So please be careful. Sometimes they are asking which of the following are the reasons for modulation and what is the need for modulation. Fourth point is why you are going for modulation is to overcome equipment limitations. This point will find in one of the engineering services exam. We go through the previous year papers to overcome equipment limitations. But this points, first 3 points already I have given an idea. Uh, but these remaining points, after some theoretical discussion only, I will explain how to, what is that equipment limitations and how to overcome that equipment limitations. Definitely, I will go to explain these points after some discussion. Fifth one, why modulation is required is for frequency allocation. Or sometimes you will find the terminology spectrum allocation also. Frequency allocation or spectrum allocation. I will attend all these points later. First 3 points explained you. The next 3 points after some theory I'm going to explain. Sixth point, why modulation is required is to convert a wide band signal into a narrow band signal. What is this wide band and narrow band? I will discuss later. I told you these 3 points, 4, 5, and 6, I will discuss in a detailed manner. For the to explain these points, some theoretical concepts are required. That is the reason for not explaining immediately. Even multiplexing also, I'm going to give a detailed analysis in FDM as well as TDM. Even noise also one major topic. All these we are going to discuss. Just I explain you what is the reason to go for modulation and various reasons for modulation. Now, I explained you the block diagram and what is the need for modulation. Next, I'm giving you review of Fourier transform. Okay, listen carefully. If you take any communication textbook, the first chapter you will find is about Fourier transform or review of signals and systems, some textbook. First thing is that what is the reason why you are studying Fourier transform here? I told you one thing. In this subject, always we are talking about frequencies. The reason also I told you, whenever you are transmitting a signal, always you have to see that there is no interference between one signal to another signal. In communications, when the interference occurs between two signals are only if the frequencies are same. Listen carefully. Whenever the frequencies are same, one signal will cause interference to the other signal. Now example is radio, FM radio. You are listening to FM radio, there are many radio stations. What is the frequency of each and every radio station is not same. But the carefully observe what the frequency of the first radio station, second radio station, third radio station, those are not same. So because if the frequencies are same, one will cause interference to the other radio station. That means what is the first objective of any first thing you have to do in communication is see this diagram. I want to know what are the frequencies present in the first signal, what are the frequencies present in the second signal, what are the frequencies present in the third signal. The very important precaution in multiplexing is that we have to see that the frequencies are not same. Then what happens when the frequencies are not same is one will cause interference to the other signal. So the first step in the analysis is to determine the frequencies present in a signal. How to determine the frequencies present in a signal is by using Fourier transform. You know very well, Fourier transform converts a time domain signal into a frequency domain signal, and by sketching the spectrum, it is possible to determine the frequencies present in a signal. So remember, Fourier transform, why it is required is to determine the frequencies present in the signal. Okay. How to determine the frequencies I will explain. Now I am taking a signal g of t. Just I am using the notation. Using Fourier transform, we can convert this time domain signal into frequency domain signal. See here it is a function of time, whereas here it is a function of frequency. This is the electrical signal. Electrical signal means function of time. What is the parameter that changes is nothing but voltage variation. Okay, this is the signal. My objective is I want to know what are the frequencies present in this electrical signal. One thing you should remember in the entire subject, it is impossible to determine the frequencies by observing this time domain signal. So how to determine the frequencies present in this signal means you have to convert time domain to frequency domain. I told that here it is a function of time and here it is a function of frequency. Now, whenever this frequency domain signal is sketched graphically, that I'm calling it as the spectrum. So spectrum is, it is nothing but the graphical representation of the frequency domain signal. Okay, just assumption. Let us assume that the spectrum of a signal is like this. I told that is a pure assumption. Okay, just I'm assuming the shape like this. Let us assume that this is 5 kilohertz. Okay, I'm saying that shape of the spectrum only assumption, pure assumption. Now, let us see here. What is the conclusion? All of you see carefully. What is the important conclusion by observing this diagram? This electrical signal, look here. This electrical signal is having the frequencies from 5 kilohertz to 15 kilohertz. Please think about what I'm saying. That means we can determine the frequencies only by sketching the spectrum. If you want to sketch the spectrum, you have to convert this time domain signal into frequency domain signal. Then only we can determine what are the frequencies present in the signal. So many examples I'm going to explain. So let us assume that this electrical signal is voice. If this electrical signal is voice, what are the frequencies? In the introduction itself, I told you what are the frequencies. See this one, 300 to 3.5. to 3.5 kilohertz. Now, suppose if it is audio, already I told you about all these points. If it is audio, frequencies will be from 20 hertz to 20 kilohertz. That means what are the frequencies present in a signal? It depends upon the nature of that signal. Is it a voice, audio, video, or any other signal is considered? Now, so I hope that it is clear to you. Generally in the interviews also being asked why Fourier transform concept is required is to determine the frequencies present in a signal. How to determine the frequencies means we are converting time domain to frequency domain and we are sketching that frequency domain signal graphically. Then only we can determine the frequencies present in that electrical signal. How to observe this signal in time domain practically? So this signal, this electrical signal, you can observe practically by using a CRO, cathode ray oscilloscope. For example, you can see your microphone. This microphone converts my voice into electrical signals. But I want to know how my voice signal changes electrically. Very simple. This microphone output, you give it a CRO and you talk, observe the electrical signal. Already I told you it is a random signal. It is not like a sinusoidal or any other deterministic signal. It is a random signal. What you will observe on a CRO is considered. Then how to observe the frequency domain signal practically? How to observe is by using a spectrum analyzer. So remember, CRO will displace the time domain signal. Spectrum analyzer will displace the frequency domain signal practically. Then once you convert a time domain signal into a frequency domain signal, the very important parameter required for our subject is the bandwidth. I am introducing many terms. Already I told you some of the students are very much thorough. They might have taken the coaching already. They will be very simple for them. There are some students who have joined newly. For those students' sake, I am explaining somewhat slowly, and I'm repeating many times. So those already attended, they may feel bored, but just for the sake of new students, I'm discussing in a detailed manner. And listen here. I want to know what is the bandwidth of the signal. You may be knowing bandwidth of the signal is different. Bandwidth of a system is different. Listen carefully. What is the bandwidth of the system? System is like an amplifier I'm take. Amplifier I'm called as a system. What is the bandwidth of the amplifier? It is nothing but the range of the frequencies where the gain of the amplifier is constant. So range of the frequencies where the gain is constant. But what is the bandwidth of a signal? Bandwidth of a signal, carefully listen. I'm giving the definition. Bandwidth of a signal is nothing but the range of the frequencies occupied by the signal. Once again, I'm repeating, bandwidth is nothing but the range of the frequencies occupied by the signal, or I'm writing like this: highest frequency minus lowest frequency occupied by the signal. Now look at this. Okay, just listen. Suppose if we take highest frequency occupied by the signal is 15 kilohertz, lowest frequency occupied is 5. So in this case, what is the bandwidth of the signal? So what is the bandwidth of the signal in this case is equal to 10 kilohertz. So sometimes the exam you'll find like this also, 10 kilohertz. Now the important point is that whether the bandwidth of the signal should be high or it should be low. Carefully think about what I'm saying is, I want to know whether the bandwidth of the signal should be high or it should be low. Listen, what I'm saying is, practically bandwidth of the signal should be as minimum as possible. Once again, I'm repeating, bandwidth of the signal should be as minimum as possible. Why the bandwidth of the signal should be minimum? All of you look at this point, multiplexing. Many times it will be asked in the interviews, how many signals we can multiplex through a communication channel? Is there any limitation? Whether we can transmit 10 signals or 100 signals or 1000 signals. If you remember, already I told you one simple example of multiplexing is cable TV. Assume that cable operator is giving you some 100 TV channels. Ask him to give another 50 channels. It is impossible. Always there is a limitation on the number of signals being multiplexed. What is that limitation is? What is the bandwidth of each and every signal? Listen, if you want to multiplex more number of signals, the bandwidth of each and every signal should be as minimum as possible. This concept will be clear to you in the topic FDM, frequency division multiplexing. So again and again I am saying, If you want to multiplex more number of signals, bandwidth of each and every signal should be as minimum as possible, and at the same time bandwidth of the channel should be as high as possible. Again and again I'm saying signal bandwidth should be minimum, but channel bandwidth should be maximum. So what is the difference between those two? That will be clear to you only in the topic multiplexing for the time being. So entire subject, my objective is to see that signal bandwidth is minimum, or always I'm thinking how to reduce the bandwidth of the signal. Okay, then the second point is channel bandwidth should be as maximum as possible. Why these two conditions? I will explain in the topic multiplexing. Again and again I'm saying today's class, try to understand the terminology in this subject. The points one by one you will be in a position to understand later. Now, what are the important parameters you have to consider in the analysis of a communication system? This is very, very important for the interviews. Some of you might have qualified even for the ISRO exam. Remember, many times it will be asked, what are the various points to be considered? Carefully see what I'm saying is. First point already I told you is, whenever you are analyzing or designing a communication system, my requirement is to see that the bandwidth of the signal should be as minimum as possible. Bandwidth of the signal I'm saying. Already most of you might have studied the subject in which, for which signal bandwidth is, for which modulation technique bandwidth is minimum is SSB. In unlock communication I'm talking about, bandwidth is minimum in the case of SSB. Second point, what is the power required to transmit the signal also should be as minimum as possible. Listen what I'm saying. Power required to transmit the signal should be as minimum as possible. Just 1 minute. Just wait for 2 minutes. The power required to transmit the signal should be as minimum as possible. So a simple example I want to give. Don't get confused. Very simple example I'm taking is a mobile phone. Mobile phone modulation is must. But what is the modulation technique you have to select for a mobile phone is, you have to select a modulation technique which requires less power or which consumes less power. The because mobile phone you are charging, it is always called as a power limited, but the power available is very much limited. So you have to select a modulation technique which consumes less power. And another example I want to give is about the satellite. We are receiving the signal from satellite. Example is TV. Nowadays, how we are getting the signal to a TV is through D2H service, direct to home, like Tata Sky and all these were called as D2H service. Now the point is, the in the design of any communication system, the very important parameter we are talking is about the signal to noise ratio. Signal to noise ratio again depends upon the uh, transmitted power, but transmitted power depends upon the type of modulation technique. The very important point is that if I use AM, what is the power required? If I use DSB, what is the power required? If I use FM, what is the power required? So when compared with all techniques, FM modulation requires less power for same conditions. Conditions means I want a signal to noise ratio of some 20 dB, 30 dB, 40 dB. If I use AM, what is the power? If I use DSB, what is the power? So remember, signal to noise ratio depends upon the power, but power depends upon the type of modulation technique. But in satellite, what is the major problem is, again, it is power limited communication system. You may be knowing satellite always generate the power from solar cells. You might have seen the picture of a satellite. On both sides of a satellite, you will find a solar panels. Satellite generate the power from that solar cells for communication point of view. So what is the power generated by that solar cells is very much limited. So you have to select a modulation technique which requires less power. So what I'm saying is that when compared with all techniques, which modulation technique requires less power is FM. So this, all these points I'm going to explain in a very detailed manner. Later I'm going to explain example take like this. If I use AM, what is the power? If I use DSB, what is the power? If I use FM, what is the power? For same conditions, if you do the analysis like that, you will come to know which method requires less power. After completing all topics, all modulation techniques, I'm taking one example. I'm fixing the conditions. I want the signal to noise ratio, noise, losses. Then I will discuss, if I use AM, what is the power? If I use DSP, what is the power? FM, what is the power? But you have to select a modulation technique which requires less power. I am saying that when compared with all techniques, FM requires less power, but which method requires more power is AM. Please remember, AM requires more power and FM requires less power. Some of the students might have gone through the previous year examination papers. You might have see the papers, especially engineering services, you will find theoretical questions. I told you GATE, most of the questions given in this subject are numerical type questions. Numerical are where calculator is required to solve the numerical problems. Now, one important point just in between, I'm giving you some points. Many students are asking about the textbooks to practice. One thing is that already I told you, exercise problems of Prokis are very much useful. One thing is that if you want to crack the GATE exam or engineering services exam or ISRO exam, what is required is about the analysis of previous year question papers. One important point is that control systems, let us say. So where to practice questions on control systems, digital. So the best thing in my opinion is that previous year paper, suppose you take control systems, previous year gate of ECE, electrical and instrumentation. These three branches, last 20 years papers, if you are able to solve, I'm saying that you will be in a position to write any exam, any competitive exam on that particular subject with 100% guarantee. What I'm saying that. So what I'm saying that my sincere advice to all students is that subject, suppose control systems, gate, ECE, gate electrical, gate instrumentation. And at the same time, engineering services, ECE as well as electrical. See, total 5 different sets last 20 years paper. It is a very large question bank that is more than sufficient if you practice all those questions if time permits. What I'm saying is that, so don't listen or don't go through any textbook. What I'm saying is that just practice the previous year paper. Suppose they take the subject digital. Again, digital also you'll find gate ECE, gate electrical, gate instrumentation, and engineering services EC as well as electrical. So this is a very, very good question bank. Suppose if you take the communication, you will find in the gate ECE and instrumentation. Electrical gate communication subject you will not find. So it is again a good collection. Again, engineering services, both EC and electrical students are also having this subject, communication. So what I'm saying that it is a very, any subject to take control systems, try to finish previous year papers. I'm saying that it will give you 199% of the questions you will be in a position to answer once you practice previous year gate instrumentation as well as EC papers. So, okay, sorry for the deviation. Now, third parameter, I told you about bandwidth of the signal should be minimum. Next requirement is what is the power required to transmit the signal. That is very important. The terminology very, very important. Should be as minimum as possible for same conditions. Next parameter is complexity of the receiver. Whenever you are designing some communication system, always your requirement is to see that the receiver complexity is as minimum as possible. So that means the design of the receiver should be as simple as possible. You may be knowing the design of the AM receiver is very, very simple, because what we are using for AM demodulation is the envelope detector. You may be knowing envelope detector hardware implementation, just a diode, resistor and capacitor, that is sufficient. So the design of the AM receiver is very, very simple when compared with any other modulation technique. Next, fourth parameter you have to take in the analysis of any communication system is signal to noise ratio. So these are the four important parameters you have to consider whenever you are comparing one modulation technique with another modulation, whether in the interviews or even for you also, which is better, whether AM is better or FM is better, PM is better. Always do the comparison with respect to these four parameters: bandwidth, power, complexity of the receiver, and signal to noise ratio. I told you practically signal to noise ratio should be very much greater than 1, and for frequency modulation, signal to noise ratio will be very, very high when compared with all modulation. So these are the four important parameters you have to consider in the analysis of any communication system or even in the comparison. So in one of the engineering services exam, later go through, it is asked which of the following are the advantages of FM over AM. They have given these points in the engineering services exam. So remember, in the interviews also being asked, what are the parameters you have to consider in the design of any communication system is considered. Now, I told you Fourier transform integral, how to convert a time domain signal into a frequency domain signal. G of t, and here I am writing G of f. Omega. Some textbooks you will find omega notation. Omega means angular frequency expressed in radians per second. But nowadays in communication, we are not at all using angular frequency. Frequency means always we are expressing in hertz. Like FM radio, I told you 88 megahertz to 108 megahertz. So like that 2G mobile phone 800 megahertz. Now see here. So how to convert a time domain signal into a frequency domain signal is by using Fourier transform integral g of t into e power minus j omega. Instead of omega, I'm writing 2 pi f. This is the Fourier transform integral, which will convert a time domain signal into a frequency domain signal. Just 1 minute. Okay, in the subject signals and systems, you are studying about various types of signals. I told you I'm giving a revision and I'm going to explain what is required for the subject communications. In that aspect only I'm talking about. There are various types of signals. One of the very important signal always I'm talking is a rectangular pulse. Now I'm talking about a rectangular pulse. What is the amplitude? I'm writing it as A. I told that amplitude always represents the voltage, and I'm assuming that the pulse width is equal to T. T represents the pulse width. It is centered at origin. So centered at origin means it is existing in the interval minus T by 2 to plus T by 2. So this is a signal which is a function of time. Now I want to convert this time domain signal into frequency domain signal. So why I want to convert time domain signal into frequency domain? Many times I'm saying I want to know what are the frequencies present in this electrical signal. I told you clearly it is impossible to determine the frequencies directly by observing this time domain signal. If you want to know the frequencies present in this rectangular pulse, you have to convert time domain signal into frequency domain signal. So this is G of T, G of F. Then how to convert time domain to frequency domain is by using this Fourier transform integral. Limits of integration from minus T by 2 to plus T by 2. If you observe, the signal is existing in the interval minus T by 2 to plus T by 2. In that interval, what is the value of the signal is equal to A. Okay, later solve the integral. and check it out. What is the answer you are going to get is 80 sin pi of t divided. Please check later. This is the answer you are going to get. Now, the important point is in the subject signals and systems. Already you might have studied about the function, sync function. How to define sync function, you know very well. Sin pi x divided by pi x. This is called as the sync function. Now, what is the sync function graphically? Function of x. Now, if you observe here, maximum value occurs at x is equal to 0. It is in the form sin theta by theta. Limit theta tends to 0, sin theta by theta is equal to 1. So maximum value occurs at x is equal to 0, but that maximum value is equal to 1. Then what is the nature of the sync function? Let us assume that this denominator is not present. If the denominator is not present about the numerator, it is a sinusoidal function, but the same parameter is present in the denominator also as x increases. What is the name? It is like a sinusoidal function only, but as x increases, what happens is that amplitude gradually decreases. Now, what is required for the subject? When the sync function becomes 0, that is very, very important in our subject. Listen carefully. When the sync function becomes 0 is, look here. Sync function becomes 0 when x is equal to plus 1 as well as minus 1. Substitute here x is equal to 1. You know very well what is the value of sin pi is equal to 0. Similarly, when x is equal to plus 2 as well as minus 2, plus 3, minus 3. So sync function when it becomes 0 is when x is equal to plus or minus 1, plus or minus 2, plus or minus 3, like this. Now, so what is the spectrum of a rectangular pulse? What is the answer? See here. See here, sin pi x by pi x. In place of x, here what we are having is equal to ft. So this I am writing it as at 80 sync ft. It is one of the very, very important relation Remember this like a formula. Many times I'm using that this formula AT sync FT. So this is the Fourier transform of a rectangular pulse. In this formula, what A represents is the amplitude of that rectangular pulse. And what this capital T represents is the pulse width, and this is not the time period. Now look here. So what is the spectrum of a rectangular pulse? Is nothing but the sync function. It is like a sinusoidal only, but amplitude gradually decreases. And what is that maximum value? I told that sync function, pure sync function means what is that maximum value is equal to 1. But look here, there is a coefficient of AT. That means what is this maximum value is equal to AT. Next, when the sync function becomes 0, that is more important. When the sync function becomes 0 is, I told you, when x is equal to plus or minus 1, plus or minus 2, plus or minus 3, like that and so on. But what is x here? In place of x here, what we are having, please carefully observe, in place of x, what we are having is equal to ft. Or the parameter I took along x-axis is f. So when the function sync function becomes 0 is when f is equal to plus or minus 1 by t, plus or minus 2 by t, 3 by t, like this. So sync function it becomes 0 when f is equal to plus 1 by t minus 1 by t. So this is the spectrum of a rectangular pulse. Some points just remember, because most of them signals and systems may be over by that subject might have been over. Now see here, some like a shortcut method, objective paper, you can think like that. What is the value at f is equal to 0? Remember, what is the value at f is equal to 0? It is nothing but the area under the time domain signal. Please all of you look here. In time domain it is a rectangle. What is the area of this rectangle? You know very well, amplitude A, width is equal to AT. Remember, this is a very, very important point in the noise analysis. What is the value at f is equal to 0 should be equal to the area under the time domain signal. Similarly, what is the value at t is equal to 0? See here, what is the value at t is equal to 0 is equal to a. It is nothing but the area under the frequency domain signal. That means what is the area of this sync function is nothing but a. Area under that sync function is equal to a. Now look here. Once you sketch the function, what is required for me is I want to know what is the bandwidth of the signal. Listen carefully, bandwidth of the signal. Already I told you, bandwidth means highest frequency minus lowest frequency occupied. What is the highest frequency occupied? Sinusoidal means theoretically it will extend up to infinite. But which is the lowest frequency occupied is 0. This is very, very important point. Listen, whenever you are calculating the bandwidth, consider only the positive portion of the spectrum. Don't consider the negative frequencies, because what is the parameter I took along x-axis is the frequency. What I'm saying is that don't consider the negative frequencies whenever you are calculating the bandwidth. The reason is practically negative frequencies will not exist. Always we are saying that frequency 1 kilohertz, 10 kilohertz, 1 megahertz. We never say that frequency is minus 1 kilohertz or minus 10 kilohertz like that. So remember, practically negative frequencies will not exist, but in the spectrum always you are sketching for negative frequencies also. What about the significance of these negative frequencies? I'm going to explain in a detailed manner later, because it is too early. Some more concepts also required. One important textbook, uh, generally for concepts point of view, for numericals only I told you Provokis and Sam series, but there is one textbook, Modern Analog and Digital Communication Systems by B.P. Lathi. This B.P. Lathi textbook is very much useful for the theoretical analysis. It is a very good book where most of your doubts will be cleared in this subject. If you go through this textbook, in the introduction itself, it is given why negative frequencies. See the first chapter itself, you will find why negative frequencies. He has given various points. If you go through that topic, he has given various points. First, he started the discussion why are using a complex number in mathematics even though they are not existing. Listen carefully. Why are using a complex number in mathematics even though they are not existing? There is some mathematical convenience. In the same way, spectrum also we are sketching for negative frequencies. There is some convenience in our subject by sketching the spectrum for negative frequencies. What is that convenience? It will be known to you later clearly. For the time being, again and again I'm saying, whenever you are calculating the bandwidth, don't consider the negative frequencies. Always you should take only the positive portion of the spectrum. That means, what is the bandwidth of the signal? Is infinite. But I hope uh, you remember, I told you clearly, bandwidth of the signal. Please see this one. I told you bandwidth of the signal should be as minimum as possible. But here I'm saying that bandwidth answer I'm getting is infinite. So my objective is always how to reduce the signal bandwidth. Please remember this point. Always I'm thinking how to reduce the signal bandwidth. Please listen carefully. How to reduce the bandwidth of a signal is by eliminating the insignificant frequencies. Again, I am repeating, you have to eliminate the insignificant frequencies. Which are insignificant frequencies in this diagram? Carefully see here. In a sync function, this is called as the main lobe. And all these are called as the side lobes. All these are remaining are called as side lobes. Then in signals and systems, you might have studied about the classification of signals. One of the classification is energy signals and power signals. See this signal. This is an energy signal. See the time domain signal. Whenever a signal is having finite duration, always you can call it as a energy signal. So this is an energy signal. You know the procedure, how to calculate the energy of a signal. What is the formula which is used to calculate the total energy of the signal? Here, signal is existing in the interval minus t by 2 to plus t by 2 square. That value I'm squaring a square into dt. So if we solve this integral, what we are getting is equal to a square t joules. This is the total energy of the signal. But how to calculate the energy? There is another method also. We can calculate the energy even from frequency. Here I'm using the time domain signal, but you can calculate the energy even from frequency domain signal. What is the formula which is used to calculate the energy is modulus of g of f whole square, integration with respect to f. But whether you are using time domain or frequency domain, what the answer should be same. A square T joules. Now listen carefully. Sometimes in the competitive exams, you will find I want to know the energy between 1 kilohertz to 10 kilohertz, or I want to know the energy between uh, 1 megahertz to 10 megahertz. Like that also you can calculate. I want to know what is the energy present in the main lobe alone. In that case, what are the limits of integration? Listen carefully. I want to know what is the energy present in the main lobe alone. So minus 1 by t to plus 1 by t g of f modulus whole square into df. What is g of f? Already known to you, at sinc ft. So calculate what is the answer you are going to get is 0.95 a square t. You will get. Please check the integrals later. So if you solve, that means the main lobe alone contains 95% of the total energy. Listen what I'm saying, 0.95. That means most of the information present only in the main lobe. Side lobe contains only 5% of the total energy. So the main lobe alone is more important for me than the side lobes. Then how to eliminate all the side lobes? Or I want to consider only the low frequencies. How to eliminate high frequencies from the signal is by using a low pass filter. So only low frequencies are the main lobe alone is important for me. Side lobes are not at all important. So the signal now passed through a low pass filter. And what is the cutoff frequency? Filter means always you are talking about cutoff frequency. What is the cutoff frequency I am taking is equal to 1 by t. Always you have to take symmetrically on the negative side also. You know very well, in a filters, this is called as the pass band and remaining is called as the stop band. So I want to consider only the main lobe alone. So if the signal is passed through a low pass filter, what is the output of the low pass filter? What is the output of the low pass filter? You will find is only the main lobe alone. All side lobes are attenuated. Only main lobe is in the pass band, remaining are in the stop band. So sync function now passed through a low pass filter. Now please think about what is the bandwidth at the output of the low pass filter. See, already I told you what is the bandwidth. Theoretically I told you is infinite. Now if you go through this, what is the bandwidth at the output of the at the output of the low pass filter? Can you guess what is the bandwidth at the output of the low pass filter? I told you clearly, don't consider the negative frequencies whenever you are calculating the bandwidth of the signal. That means what is the bandwidth at the output of the low pass filter? So what is the bandwidth at the output of the low pass filter is nothing but 1 by T hertz. That means the bandwidth of the signal is inversely proportional to the pulse width. What is the theoretical bandwidth? If you remember, what is the bandwidth of the signal? Here it is infinite. Theoretically, what is the bandwidth of the signal is infinite, but how we are in a position to reduce the bandwidth is by eliminating all the side lobes, because the main lobe alone contains 95% of the total energy. So this is the called a theoretical bandwidth, whereas this is called as the practical bandwidth. So practical bandwidth is inversely proportional to the pulse width. Remember that point, it is inversely proportional to the pulse width. Now I want to explain the concept in a detailed manner. All of you listen carefully. It is a very, very important concept. I'm considering a rectangular pulse. What is the spectrum of a rectangular pulse? Means a sinc function, and I'm considering only the main lobe alone. Assume that the pulse width is equal to 1 millisecond. Pulse width is equal to 1 millisecond. Then what is this value? Pulse width 1 millisecond means what is this value is equal to 1 by T. What is the value of T is 1 millisecond means what is this value is equal to 1 kilohertz. Now the important point is theoretically it is having frequency components up to infinite. But which is the highest significant frequency is 1 kilohertz. Sometimes it will be asked in the question, which are the uh, significant frequencies. In this example, significant frequencies are 0 to 1 kilohertz, because this main lobe alone contains 95% of the total energy. All remaining side lobes contains only 5%. Now look here again. Assume that the pulse width is 1 microsecond. If the pulse width is 1 microsecond, which is the highest significant frequency? Which is the highest significant frequency is 1 megahertz. Or what is the bandwidth of this signal is also practical bandwidth. I'm saying practical bandwidth is 1 megahertz. In signals and systems, you might have studied, whenever a signal is compressed in time domain, it will be expanded in frequency. Means remember, signal, if it is compressed in time domain, it will be expanded in frequency domain. It is impossible to limit the signal both in time domain as well as in one domain. If you try to limit other domain, it will be expanded. What will happen whenever the pulse width approaches 0? Whenever the pulse width approaches 0, it becomes a impulse function. What is the Fourier transform of a impulse function? You might have studied delta t. So what is the Fourier transform of delta t is equal to 1? That means what is the spectrum of the impulse function is a constant value of 1, or what is the bandwidth of a impulse function is infinite. So remember, I gave the introduction why you are studying Fourier transform. Fourier transform concept is required to determine the frequencies present in a signal. Suppose you take in the first slide itself, I told you the binary data is represented in the form of a rectangular pulse. What are the frequencies present in a binary data depends on the pulse width. If the pulse width is 1 millisecond, what is the highest significant frequency is 1 kilohertz. If the pulse width is 1 microsecond, highest significant frequency is 1 megahertz. So remember, by sketching the spectrum only, it is possible to determine the frequencies, and also we can determine the bandwidth of the signal. Now look here. What is the Fourier transform? What is the Fourier transform of a impulse function? Fourier transform of this impulse function is equal to 1. Then what is the Fourier transform of 1? Already some student subject is over, or may be having some idea about this. What is the Fourier transform of 1? There is one property called as duality property of Fourier transform. What is the Fourier transform of 1 is equal to delta f. In omega notation, you might have studied it as 2 pi into delta of omega, but I'm not at all using omega notation. In F notation, 2 pi will not come. So please remember. So Fourier transform of impulse function is equal to 1. And what is the Fourier transform of 1 is nothing but a impulse function. Now listen carefully. So impulse function will exist only at t is equal to 0, but the area under the impulse function is equal to 1. It is not the amplitude. Now, what is the Fourier transform of a impulse function? I told that Fourier transform of a impulse function is a constant value of 1. Now I want to know what is the Fourier transform of a constant. What is the Fourier transform of a constant? According to duality property, it is nothing but a impulse function at f is equal to 0. So what is the spectrum of a impulse function is equal to 1, or what is the spectrum of 1 is nothing but a impulse function. Now what is the significance? Now always think in that manner. Why are sketching the spectrum? I told you clearly, we are sketching the spectrum to determine the frequencies present in a signal. So see here, what is the signal in time domain? All of you see carefully. This is the signal constant. I told that what the amplitude represents. I told you clearly what the amplitude represents is the voltage. Voltage is constant. Voltage constant means this is nothing but a DC signal. Listen carefully what I am saying is. Now you know very well what are the frequencies present in a DC signal. DC signal means you know very well what is the frequency is 0. That is why an impulse function present at f is equal to 0. Please all of you see carefully. What I am saying is that spectrum, what it indicates is the present frequency is present in this signal. What the frequency of a DC signal is 0. That is why there is an impulse function at f is equal to 0, or what it indicates is what the frequency of that electrical signal is 0. So listen to the all these points. So DC also many times it is required in our subject. So I told you about a rectangular pulse. What is the spectrum is nothing but a sinc function. What is the spectrum of a impulse function is equal to 1, or what is the spectrum of a constant? Constant means DC signal. What is the spectrum of a constant is nothing but a impulse function, and where that impulse function is located is at f is equal to 0. Located at f is equal to 0 means what the frequency of that signal is 0. Now, like this, many signals you will be studying, but don't worry. What is required for communication subject only, I am giving a revision. So, please be thorough whatever I am explaining. Not all other signals, not at all required. I told you about first rectangular pulse, impulse function, constant, like this. Now, you might have studied various properties of Fourier transform. Listen carefully, properties of Fourier transform like linearity property, time shifting property, time scaling property. Those properties, not all properties are much useful. Only frequency shifting property is very much useful for us, because frequency shifting property, it is also called as modulation property, another name for this one. So based on that frequency shifting property, I want to give the introduction to the topic modulation. What is meant by modulation, and how to do the modulation, that analysis I'm going to give in a detailed manner, but I will continue with 20 minutes break. So uh, please stay connected. I will continue the class with 20 minutes break. Many students raising the doubt, but I will attend your doubts only at 1 p.m. After completing the class only, I will be in a position. Please wait till that time. So now I will continue the session with 20 minutes break. Okay. So some students have posted it is not audible, but we checked everything is okay. Please check from your side also settings in your mobile phone. The settings here, everything is clear because some two or three students posted it is not audible. And uh, some students asked about the notes or definition. You know very well this video will be available for 2 or 3 days. You can download or you can uh, listen to the lecture again and try to write the notes. So it is very difficult to it is every point, but I'm trying to uh, explain the topic very slowly here afterwards. Just try to understand the problem. The some of the students are asking about the syllabus. Why? What is the reason for not explaining the syllabus? Is all of you are having the volume 1 and volume 2 in both the books, first page or second page, you will find the syllabus in a detailed manner. Please go through the syllabus in the net. You can browse or you see the volume 1 clearly. Both the books, volume 1, volume 2, in all the books, whatever is supplied to you, syllabus is mentioned to you clearly. So please go through the syllabus is considered. Okay, now I'm explaining you what is the concepts required for the subjects is considered. Already I told you about Fourier transform. The sorry. Now various properties of Fourier transform are there, but most important is only frequency shifting property or modulation property. Frequency shifting property. I told you another name for this is modulation property. Try to understand this concept carefully. I'm considering a signal g of t. The Fourier transform of the signal g of t is equal to g of f. Listen carefully. The Fourier transform of the signal g of t is equal to g of f. Now, this electrical signal g of t is multiplied with the sinusoidal signal cos 2 pi fct I have written. Whenever the electrical signal is multiplied by a sinusoidal signal, what is the Fourier transform? First, understand. I will explain in a detailed manner. Now see here. This is what I'm calling it as frequency shifting property or modulation property. So this property is very much useful in the entire subject. Now see carefully what is the analysis. Signal g of t is now multiplied by a sinusoidal signal. This sinusoidal signal in our subject, we are calling it as the carrier. And this FC, I am calling it as carrier frequency. This FC, I'm calling it as carrier frequency. Now, carrier, please listen to the points I'm saying. Carrier is always a high frequency sinusoidal signal. Once again, I'm repeating, carrier is always a very, very high frequency sinusoidal signal. Why the carrier should be a very, very high frequency? Already I told you about what is the reasons to go for modulation. I have explained you what is the reason to go for modulation. One of the reasons, if you remember, see here, to reduce the size of the antenna. I told you clearly, we are converting a low frequency signal into high frequency signal. How to convert a low frequency signal into a high frequency signal? That is possible uh, by multiplying the signal with carrier, that I'm going to explain. So carrier here afterwards, remember, it is a very, very high frequency signal. What is that high frequency? In the case of a 2G mobile phone, frequencies starts from 800 megahertz. And in the case of a FM radio, frequencies starts from 88 megahertz to 108 megahertz. And in the case of a radar and satellite, carrier frequencies will be in the range of gigahertz. So once again I'm saying, please observe, carrier means always it is a very, very high frequency signal. One of the reasons I told is to reduce the size of the antenna. And carrier, always it should be a sinusoidal signal. Why it should be a sinusoidal? Again, some concepts, please wait for some time. I'm going to explain. The all of you may be having some idea. Carrier means it should have only one frequency. Which signal consists of only one frequency is sinusoidal signal. Suppose take any other signal like a ramp signal, triangular signal, rectangular signal, any signal you take, they will be having multiple frequencies. But so many times, you know very well, FM radio, FM means frequency modulation. All of you are listening to radio. What is the frequency of the first radio station? In Hyderabad, 91.1 megahertz. Second radio station, 92.7 megahertz. What is that 91.1 megahertz? 92.7 megahertz. Those are nothing but carrier frequencies. So remember, carrier means it should have only one frequency. Which signal consists of only one frequency is sinusoidal signal. So remember, carrier means it should be a very, very high frequency sinusoidal. Here I used cos. Sinusoidal means it can be cos term or even it can be sin term also. There is no difference. Later I will give that clarity to you why it should be cos or sin also. That clarity later I'm going to explain. It can be cos or even it can be sin also. Now, what is the important point you have to observe? Please, all of you listen this point carefully. Whenever a signal is multiplied with the carrier, what happens to the spectrum? All of you is here. This is G of F. Look here, this is G of F minus Fc. How to interpret G of F minus Fc? Please think carefully. G of F minus Fc, how to interpret is the spectrum of the signal. It is shifted to the right side by Fc. Please think what I'm saying is spectrum of the signal is shifted to the right side by Fc. What is G of F plus Fc? The spectrum of the signal is shifted to the left side. So please remember entire subject. Whenever a signal is multiplied by the carrier, what happens to the spectrum? Spectrum of the signal is shifted to the left side and also to the right side. How much it is shifted to the left side and right side? It completely depends upon the carrier frequency. And what is the another change out observe is that amplitude becomes half. Again, I am writing, if a signal is multiplied with carrier, the spectrum of the signal is shifted to the left side and also to the right side, and amplitude becomes half. Please listen to this point. What I'm saying is, now I want to explain the concept in a detailed manner. Why it is called as frequency shifting property? Why it is called as frequency shifting is the frequency domain signal is shifted to the left side and right side. That is the reason it is called as frequency shifting property. Now I want to explain why it is also called as modulation property. Now this is more important for our subject. Please carefully understand what I am saying is. This is the time domain, whereas this is the frequency domain signal. I'm considering a rectangular pulse. Amplitude is equal to A, pulse width is equal to T. Already I explained you what the spectrum of a rectangular pulse. It is nothing but a sinc function, but I'm considering only the main lobe alone. The reason I told you, main lobe alone contains 95% of the total energy. Okay. Now, this signal, what is this signal? This is nothing but G of T. You see, G of F. Now, what I'm saying is that this signal, now it is multiplied. The signal is now multiplied by a very, very high frequency sinusoidal signal. Just observe what I'm writing is. Okay. So what is this signal? So this signal is the carrier cos 2 pi fct. Now these two signals are multiplied. Okay, now look here. When these two signals are multiplied, already I told you what happens to the spectrum. Look here. What happens is spectrum of the signal is shifted to the right side and also shifted to the left side, and amplitude becomes half. Now look here. Carefully think about signal multiplied by the carrier. What I'm saying that the spectrum of the signal is now shifted to the right side. Where it is shifted to the right side means it is shifted to FC, and also it is shifted to the left side. Left side means where it is shifted is equal to minus FC. So spectrum shifted to the left side, right side, but the another change I told is amplitude becomes half. Look here. So frequency shifting property. I told that why it is called as spectrum of the signal is shifted to the left side and right side. That is why I'm calling it as frequency shifting property. Now, why it is also called as modulation property? Look here. I told you already, modulation means it is nothing but the process of converting a low frequency signal into a high frequency signal. Now carefully observe. Let us assume that this pulse width t is equal to 1 millisecond. If the pulse width is 1 millisecond, what is this value? This value becomes 1 kilohertz. Now look here. This signal, it is impossible to transmit into free space. Why it is not possible to transmit the signal into free space is because the signal, it is having significant low frequencies. Carefully think, what are the frequencies present in the signal are 0 to 1 kilohertz. Please remember, 0 to 1 kilohertz means signal is having significant low frequencies. So whenever a signal is having significant low frequencies, wavelength lambda will be very, very high, and the size of the antenna also will be very, very high. So it is impossible to transmit the signal directly into free space. Now, how to overcome this problem? Now I'm taking the carrier. Let us assume that the carrier frequency is 100 megahertz. The carrier frequency 100 megahertz means the spectrum of the signal where it is shifted is equal to is 100 megahertz. The spectrum of the signal, now it is shifted to 100 megahertz. That means the frequencies are now in the range of 100 megahertz. What is this value? 100 megahertz plus 1 kilohertz, and this is 100 megahertz minus 1 kilohertz. So what I'm saying is that the spectrum low frequency signal now converted into a high frequency signal. How it is converted is by multiplying the signal with carrier. This is what I'm calling it as modulation. So entire subject, whether it is analog communication or digital communication, no change in the fundamental concept is considered. Modulation means what we have to do is signal should be multiplied with the carrier. What happens when the signal is multiplied with the carrier is, in this case, the spectrum of the signal is shifted to 100 megahertz, or I'm saying that signal is modulated to 100 megahertz. Please listen to this point. I'm saying that the signal is modulated to 100 megahertz. Suppose in the case of radar and satellite, carrier frequencies will be in the range of gigahertz. So the spectrum will be shifted to the gigahertz range. So Remember, very, very simple, how to modulate the signal or how to shift the signal to high frequencies. Very, very simple, multiply with the carrier. So if the carrier frequency is 1 megahertz, just I'm taking a very low value for convenience. In that case, the spectrum of the signal where it will be shifted is equal to is 1 megahertz or 1000. Now look here, the spectrum of the signal is shifted to 1 megahertz means what about this value? This becomes 1001 kilohertz, whereas this value becomes 999 kilohertz. So I'm saying that signal modulated to 1 megahertz or the spectrum of the signal is shifted to 1 megahertz. So this is what I'm calling it as modulation. This point so many times I'm repeating. The reason is because complete subject is this only. How to modulate means signal should be multiplied with the carrier. Carrier means it is a very, very high frequency sinusoidal. Sinusoidal means it consists of only one signal. So what I'm saying is that spectrum of the signal is shifted to 1 megahertz. Now I'm giving you the definition of modulation. How the modulation is defined. In the textbooks, it is interpreted in various ways. The definition of modulation is considered. I'm giving you what are those definitions are. Modulation, it is defined as the process of converting a low frequency signal into a high frequency signal. So this is the fundamental definition I can say. Then what is the second definition? Second definition is in the textbook. See the textbook Simon Akin. In that book, what is given is modulation. It is defined as the process of frequency translation. It is defined as the process of frequency translation. What is the meaning? By the process of frequency, what is the meaning of frequency translation is by modulation, the spectrum of the signal is shifted. Please look here, from low frequency region to high frequency region. Again, listen to the point. By modulation, the spectrum of the signal is shifted from low frequency region to high frequency region. That is called as frequency translation. Spectrum of the signal low frequency region to high frequency region. That process I'm calling it as frequency translation. Then what is the third definition? Modulation, it is defined as the process of converting a low pass signal. Please look here. Low pass signal now converted into a band pass signal. Band pass means, you know very well, it occupies only certain band of frequencies. Here, what is that band? Look here, 999 kilohertz to 1001 kilohertz. So some of the textbooks it is given, it is a process of converting low pass signal converted into a band pass signal. Fourth definition. What is meant by modulation? Look here. Modulation, fourth definition is, first I'm writing, it is the process of converting a wide band signal into a narrow band signal. Process of converting a wide band signal into now, what is meant by wide band and what is meant by narrow band? That is more important. Whenever the ratio between highest frequency to lowest frequency, whenever the ratio between highest frequency is very much greater than 1, then it is called as a wide band signal. Whenever the ratio between highest frequency to lowest frequency, if it is approximately 1, then it is called as the narrow band signal. It is called as the narrow band signal. For example, take a audio signal. In the introduction itself, audio means 20 hertz to 20 kilohertz. Now think about, is it a wide band or narrow band? Take the ratio 20 kilohertz to 20. What is the answer? 1000, very much greater than 1. So this I am calling it as a wideband signal. Then the by modulation, I told that wideband signal. Now see here, in this case, highest frequency is equal to 1 kilohertz. Please all of you look here. Lowest frequency 0. Don't take the negative frequencies. Ratio is infinite. So I'm considering this as a wideband signal. Now, after modulation, look here. Highest frequency occupied is 1001 kilohertz. Lowest frequency occupied is 999 kilohertz. What is this ratio is approximately 1. So this I'm calling it as a narrow band signal. So by modulation, wideband signal is now converted into a narrow band signal. So please remember this point is considered. So what is the advantage of converting wideband to narrowband? That in the analysis it will be clear to you. So definition of modulation I interpreted in 4 ways. First definition is process of converting a low frequency signal into high frequency signal. Second definition I told is process of frequency translation. What the meaning is? Frequency translation means the spectrum of the signal is shifted from one region to another region. In this case, low frequency region to high frequency region. That I am called as frequency translation. Third definition I gave is, it is the process of converting a low pass signal into a band pass signal. And fourth definition I told, process of converting a wide band signal into narrow band. Clearly explain what is meant by wide band and narrow band. What is the reason when converting a wide band into narrow band? I am going to explain in a detailed manner. Some students saying that voice is not coming. So is it the problem with all students? Can you post in the question answer? Because there is no problem from my side. Please check your settings whether the problem with all students or only few students, means you have to check. Please tell me the question and answer. Please post me, because many students are saying that yes. Okay, I'm getting the response, no problem at all. So please, some of the students check with your mobile phone. There may be some settings problem may be there, or some internet connectivity may be a problem. Please check yourself. As per my knowledge, because many students are responding, no sir, like that. Please check yourself, because I'm getting the response. It is clear like that. Many of the students are giving the same response. Okay, listen. Okay, please check the settings in your system. Okay, now please listen here. So whenever it is asked in the interviews, what is the definition of modulation? Generally, communication subject means definitely you will find the questions on modulation. What is the definition of modulation? Listen, definition of modulation, always it is interpreted in two ways. Definition in time domain, definition in frequency domain. Please listen to this point. Any doubts also later, the uh, finally I'm going to attend. Again I'm saying. So if you see these four definitions, whatever I have given are applicable in frequency domain. Please remember what I'm saying is, always you can interpret in time domain and in frequency domain. Why I'm saying that these questions for uh, definitions are applicable in frequency? All are process of converting low frequency to high frequency. I'm talking in terms of frequency. Second one, frequency translation. Again, I'm talking in terms of frequency. Low pass signal, low frequency signal converted into band pass signal. So again, I'm talking in terms of frequency only. Wide band to. So all these four definitions are applicable in frequency domain. Please remember that point. Later, I'm going to give what is the definition of modulation with respect to time domain. So please have that clarity whenever you are answering the question in any interview or that one. But I'm going to give a clear idea as far as today's class is concerned. Please revise 2 or 3 times, because basic concepts I'm going to give only in today's class, because once you are able to understand, it will be very, very easy to understand the rest of the topics are considered. Now, I want to explain the concept of modulation as well as demodulation. But before that, one thing, what is the Fourier transform of cos 2 pi fct? I will tell you later about sine, why I am not using sine term. Sinusoidal means it can be cos term or even it can be sine term. What is the Fourier transform of cos? Please think about. Some of you know the answer. Just think about what will be the answer. But think the answer not in omega, in terms of f. In omega, always you will be getting pi term. Please remember that point. Whereas in F notation, you will not get any pi term at all. Please see here what I am writing is. Please see this. Delta of F minus Fc see this one. So this is the Fourier transform of cos. If we remember in omega notation, what is the formula is pi into delta of omega minus omega c delta of omega plus omega c. So this is the, but I am not at all using omega notation. I am using only pi notation. So don't consider this. Just to have an idea only, explain that formula. Now look here. Repeatedly I am telling, understand the fundamental concepts. In this subject, concepts are more important. Many questions given on basic concepts only. Once you are having a thorough idea about concepts, subject is not at all difficult. Please remember, I'm saying that point. Later you can think and even we can discuss also later about this one. Now look here. Please understand this, what I'm saying is. Okay, this is the signal. Signal means what I'm talking is about the carrier. So coefficient 1 means amplitude varies from -1 to +1. Then think about what is the spectrum of this signal. Look here. Carefully think about what is the spectrum of this signal. Delta of F minus Fc, that means impulse function where it is shifted is equal to plus Fc, as well as impulse function it is shifted to minus Fc. And what is the coefficient is equal to 1 by 2. Please listen, I'm using the word coefficient. Don't call it as the amplitude. Whenever you talk about impulse function, what we are talking is only the area. But the area under this impulse function is 1 by 2 area. So instead of using the word area, always I'm using the word coefficient. So coefficient here plus here 1 by 2 and here also 1 by 2. So when impulse function shifted to the left side as well as right side and area becomes half. Now, what is the interpretation required? One thing, all of you listen carefully. Why we are sketching the spectrum? I told you clearly, we are sketching the spectrum to determine the frequencies present in the signal. Now, all of you see the diagram and think in that aspect. Again, I'm saying to determine the frequencies present in the signal. Can you think how many frequencies are present in the sinusoidal signal? Don't consider the negative frequencies. Please, my dear students, don't talk about negative frequencies. Please see only the positive portion of the spectrum. If you see the positive portion of the spectrum, how many frequencies are present is only one frequency. What is that frequency is equal to Fc. Again and again I'm saying, don't talk about negative frequencies. What is the significance of negative frequencies? I will explain clearly that point, but you have to wait for some time because some concepts are required. That is why I'm not discussing immediately. Now look here. So sinusoidal signal consists of only one frequency. In this case, what is that frequency is equal to FC? Don't see the negative frequencies. Repeatedly, I'm telling that point. Now, see, this is the Fourier transform of the carrier. Now, I'm talking about uh, the concept of modulation and demodulation. Now, before that, I want to explain the terminology and notations used in this subject. Terminology and notations. First, the major problem in this subject is the notations used in various textbooks and various examinations also. Some subjects notations are very much standard, like control systems, many of the notations are standard. But in this subject, the problem is with the terminology as well as notations. Now look here, always I'm using the notation m of t to represent the message signal, using the notation m of t to represent the message signal. Message signal means it can be a voice, audio, video, or even it can be binary data also. Sometimes it is also called as the modulating signal. Sometimes it is also called as the baseband signal. See here, in the question sometimes message signal, modulating signal, or even baseband signal. Generally, the term baseband, when you have to use, whenever any signal, if it is having significant low frequencies, listen carefully, whenever a signal is having significant low frequencies, that we can call it as a baseband signal. Remember, again I'm repeating, any signal having significant low frequencies, you can call it as baseband signal. Then what is the Fourier transform of m of t? Fourier transform of m of t is equal to m of f. This is the signal in time domain. Then what is the spectrum of the signal? If it is sinusoidal, two impulse functions, rectangular function, sinc function, impulse function constant, but most of the practical signals are random signals. So what is the spectrum of a signal? The shape of the spectrum I'm assuming like this. Carefully think what I'm writing is. So this is nothing but m of f, spectrum of the signal. Listen again. Practically, what the spectrum of a random signal will not be triangular. Just shape is only assumption. What is more important in our subject? Repeatedly, I'm telling frequencies. So don't see the shape of the curve, see the frequencies. So what are the frequencies present in the signal are 0 to W. This is not omega. Please listen carefully. So this is not omega. This is W. So signal is having the frequencies from 0 to W. What is W? W is always considered as the highest frequency of the message signal. W always I'm calling it as the highest frequency. Shape of the spectrum practically will not be triangular. Repeatedly I'm telling it is only assumption. Now what is this W? Please all of you think carefully. Suppose if the message is audio, think about what is W. You know very well, already I gave in the introduction. What is the value is 20 kilohertz. So what is the value of W is 20 kilohertz. What W represents is the highest frequency of the message. Suppose if the message is voice, what is the highest frequency is 3.5 kilohertz. Now carefully understand what I'm saying is, next notation I'm using is C of T. This is the notation I'm using to represent the carrier. What is the carrier? All I told that carrier means it is a very, very high frequency sinusoidal signal. Now think carefully, what is the Fourier transform? Already I told you what is the Fourier transform of cos. Please see here, what is the Fourier transform is equal to AC by 2 delta of F minus Fc delta of F plus Fc. That means what is the spectrum of the carrier? Okay, directly I'm sketching one impulse function where it is located is equal to plus Fc, and where the other impulse function is located is at minus Fc. Then what is the coefficient here? What is that coefficient is AC by 2. Don't call this as the amplitude. Impulse function means always I'm talking about the area, AC by 2. So now, so what is the area is AC by 2. So now, you know very well, carrier means it is having only one frequency. In this case, what is that frequency is equal to Fc. Then what is the other notation always I'm using is S of T. This is the notation I'm using to represent the modulated signal. You know very well, already I told you how to modulate the signal. Already I told you how to modulate the signal is signal should be multiplied, message signal multiplied with carrier. What will happen when the message signal multiplied with carrier? Already I explained you. Whenever a signal multiplied with carrier, look here. See here, see this diagram. Whenever a signal multiplied with carrier, spectrum shifted to the left side and right side. If the carrier frequency 1 megahertz, spectrum of the signal where it is shifted is equal to 1 megahertz. I'm saying that signal is modulated to 1 megahertz. So again and again I'm saying, so how to modulate the signal? In order to modulate the signal, what you have to do is the spectrum of the signal is the signal is multiplied with the carrier. So no change in the fundamental concept, whether you are studying analog communication or even digital communication, no change in the fundamental concept. So modulation means signal multiplied with carrier. So I explained you what are the notations as well as the terminology used in the entire subject. Always three terms: message, carrier, modulated signal. Entire subject we are talking about these notations. Next, I want to explain what is the concept of modulation as well as demodulation. Concept of modulation and demodulation. Okay, now try to understand this, because once you are able to understand this, very easy to analyze any modulation technique is considered. Now look here. See, I'm considering a message signal M of t. Carefully think about what I'm explaining is try to understand. Just I'm little bit slow in explaining this concept. What is the spectrum of the message signal? I told that always I'm assuming the shape as triangular, but practically it is not triangular. Just only my assumption, that's all. I'm completely following the notations given in the textbook Simon Hakin. Okay, this is M of F. Carefully think. What I'm saying is, I want to transmit this signal into free space. Is it possible or not? Please, all of you think. It is impossible to transmit the signal into free space. What is the reason? Please think about it. The signal, it is having significant low frequency components. It is having frequencies right from 0 to W. Whenever a signal is having low frequency components, major problem is size of the antenna required is very high. So I'm not in a position to transmit the signal directly into free space. Then how to overcome this problem at the transmitter side? How to overcome this problem at the transmitter side is by modulation. Listen carefully. The by modulation. What is meant by modulation? I told you clearly, modulation means message signal should be multiplied with carrier. No change in this fundamental concept. So signal, whenever a signal, this is what I'm calling it as modulated signal. What will happen whenever the signal is multiplied with carrier? I told you clearly the spectrum of the signal, now it is shifted to the left side as well as to the right side. Spectrum of the signal shifted to the left side and right side. What is the another change? I hope that remember what is the another change is amplitude becomes half. This is what I'm calling as frequency, the translation. So the spectrum of the signal is now shifted to FC. FC, you know very well, it is very, very high. So the size of the antenna is not at all a problem. So entire subject, remember modulation. Whenever I'm saying that signal is modulated, how the signal is modulated is by multiplying the signal with carrier. So signal multiplied with carrier, then only the signal is modulated or spectrum of the signal is shifted to FC. Then for any modulator, one input is nothing but the message signal. What is the another input? Another input is the carrier. Carrier is nothing but a sinusoidal signal. How a sinusoidal signal is generated? By using a oscillator like a Hartley oscillator or Colpitt's oscillator. So we are generating the carrier. What is meant by modulation? Again, I'm saying modulation means message signal multiplied with carrier. This is nothing but the modulated signal. Now this modulated signal is transmitted through the communication channel. Now what happens at the receiver side? What is the input to the receiver? What is the input to the receiver is nothing but the modulated signal. What is the role of the demodulator? Look here, what is the role of the demodulator? Demodulator role is to convert this high frequency signal back into low frequency signal. Listen carefully. The role is to convert high frequency signal back into low frequency signal. Or what is the role of a demodulator is, again, we should be in a position to get back the same message signal at the receiver side. Then how to demodulate the signal? Concept is very, very simple. Now look here. I told you at the transmitter side, modulation means we are multiplying with the carrier. So at the receiver side, what is required is demodulation. Then how to demodulate the signal? Very, very simple. Again, you have to multiply with the same carrier. Listen carefully. Modulation means what we did is multiplied message signal multiplied with carrier. Then what I'm saying is demodulation means again you have to multiply with the same carrier. Please remember, very, very simple. So what I'm saying is, once again you multiply with the same carrier. Listen, what will happen if you multiply with the same carrier? So what is the output of the multiplier? Look here. S of t multiplied with, but what is S of t? Look here. What is S of t is nothing but message signal, modulated signal multiplied with carrier. So at the receiver side, modulated signal again multiplied by the same carrier. Cos square theta, you know very well, cos square theta, you can write it as 1 plus cos 2 theta by 2. Carefully understand. 1 plus cos 2 theta by 2. Now, what is my requirement at the receiver side? Once again, I should be in a position to get back the same message signal. That means this second term is not at all required. So how to eliminate this second signal? Now carefully think about it. That second signal is a very, very high frequency signal. How I am coming to that conclusion? Please think about it. How I am coming is, it is in the form message multiplied by the carrier. Once a signal multiplied by the carrier, it becomes a very, very high frequency signal. So how to eliminate this high frequency signal is by using a low pass filter. So the second term eliminated in the low pass filter. What is the output of the low pass filter is only m of t by 2. That by 2, it is only a scaling factor. Scaling factor means just the amplitude is reduced or amplitude becomes half. Very easily we can remove that amplitude scaling factor by using a amplifier. What is the gain of that amplifier is equal to 2. In that case, what is the output you are going to get is equal to m of t. Now, please think about it, because this is the concept of modulation as well as demodulation. This concept is applicable to analog as well as digital modulation techniques also. Digital means you are talking about ASK, FSK, PSK, QPSK. There also this concept is applicable. So that is I'm saying that concept of, so again and again I'm saying, so here afterwards what you are thinking, modulation means multiplication with carrier. Message signal multiplied by carrier. Then what is meant by demodulation? Simple. Again, the modulated signal is multiplied by the same carrier and then passed through the low pass filter. So repeatedly I'm telling, please have a clear idea about this topic. Go through again and again. Please have a clear idea. Any doubts, get it clarified tomorrow. Yeah. Immediate, generally my policy always what I'm saying is that whenever I'm teaching, always you have to think. Uh, don't ask the doubts immediately. You have to give some time. You have to think the question. Whenever you think in multiple directions, then you will not uh, forget that concept. So generally, students will ask for a doubt immediately as soon as teaching. But when you think, then only your knowledge will improve. You will ask or you discuss. Through discussions, our knowledge will improve a lot. So if I give the answer immediately, you will not think at all. So my sincere advice is, once a class is over, go through once, write all points, and where you are having the doubt, then try to clear the doubt, because this live classes will be over, then I may not be available later also. So try to finish the utilize this time. So the finish today's class, and later the tomorrow what I'm saying is that revise, and then only I will be in a position to clear your doubts. Now see here, what I'm saying is that so modulation means multiplication with carrier, demodulation means again multiplied with the same carrier. Now all of you see here, especially objective papers, spectral analysis will be very much useful than mathematical analysis. In objective papers, how quickly we are solving the question is more important than solving a question in a descriptive paper. So how quickly you are getting, that is more important. What I'm saying that sometimes you have to follow some simplified methods also. Now look here, spectral analysis is very simple than time domain analysis. I told you this is the spectral, all of you look here, this is the spectral analysis of the transmitter. Now I want to know what is the spectral analysis of the receiver. What is the input to the receiver? Is nothing but the modulated signal. Now what I am saying that this modulated signal is applied as the input to the demodulator, now multiplied with carrier. Please remember this point. Whenever a signal is multiplied with carrier, what will happen to the spectrum? I told you clearly, spectrum of the signal will be shifted to the left side as well as right side, and other change I told is amplitude becomes half. Now remember that point. Various ways of doing the analysis. Now always my procedure is to follow positive frequencies and negative frequencies, apply that concept carefully. Now all of you think carefully, what will happen when the spectrum of the signal shifted? All of you see this diagram. Spectrum, I'm talking about now only positive frequencies. So the spectrum of the signal, where it will be shifted to the right side. Right side means where it is shifted is equal to 2fc. Now where it is shifted to the left side, where it is shifted to the left side means it is shifted to 0 or it is shifted to the origin. What is the other change here? K by 2 means here it becomes K by 4. K by 4. Then same concept you have to apply for negative frequencies also. That is what I told. What is the significance of negative frequencies? You will be in a position to understand care once you follow the subject. What I'm saying is, whatever you did for positive frequencies, same thing you do for negative frequencies also. So the spectrum of the signal shifted to the left side. Where it is shifted to the left side means minus 2fc K by 4. Now it is shifted to the right side. Carefully see this point. Shifted to the right side means where it is shifted is equal to 0. Already one component is there. Now another component also comes here. Please see carefully what I'm saying is. So spectrum shifted to the left side. Now there are two components at origin. You may be knowing, whenever two signals are overlapping, what is the resultant amplitude? Resultant amplitude is amplitude of the first signal plus amplitude of the second signal. So K by 4 plus K by 4. What is the amplitude it becomes is, now it is K by 2. Please think about it. What I'm saying is, amplitude becomes K by 4. Now, after multiplication, what is the next step? It is passed through the low pass filter. Whenever it is passed through the low pass filter, these two are eliminated, because what is the frequency is 2fc. Then what is the output of the low pass filter? All of you look here. Output of the low pass filter is m of t by 2. M of t by 2 means here K, and here what I got is K by 2. That amplitude scaling factor, very easily you can eliminate by using a amplifier. But the gain of that amplifier is equal to 2, and once again you will be in a position to get back the message signal. Now this is the mathematical analysis, whereas this is spectral analysis. Once again I am explaining because many students are asking doubts regarding this topic. See, this is the spectral analysis of the transmitter multiplied by the carrier. Spectrum shifted to the left side, right side, and amplitude becomes half. Same thing at the receiver side, multiplied by the same carrier. What I'm saying, that what is the input to the demodulator? Modulated signal. That modulated signal, carefully think, shifted to the left side, right side. This is also shifted to the left side as well as right side. Now at the origin, two components are getting added up. That is why k by 4 plus k by 4, it becomes k by 2. I hope that it is clear to you. Again, please go through once and ask the doubts tomorrow, not today. Please think about these concepts what I have given is. So modulation means multiplication with carrier. Demodulation means again you have to multiply with the same carrier and pass it through the low pass filter. Now, whatever I have explained is the fundamental concepts uh, of this subject is considered. I gave you what is the some one of the student asked what is the basic subject required. Basic subject required is signals and systems. Signals and systems also, not entire subject is not required, especially the Fourier transform is required. Already explained you what is Fourier transform, why you are using Fourier transform, and mainly the frequency shifting property I have explained. So this basic idea is sufficient to start the subject. Now I'm starting the subject. Whatever I have explained is only fundamentals, that's all. You know very well, subject is classified into two types: analog communication as well as digital communication. So the first I'm starting analog communication systems. Later we are talking about digital communication systems. So the heading: analog communications. Already I told you the subject divided into two parts: analog as well as digital communication systems. One thing is that nowadays most of the questions, that means not most, majority of the questions what you are getting is from digital communication only. But once you are able to understand analog communication, then only you will be in a position to attempt digital communication questions. But engineering services equal weightage for both analog as well as digital communication. Please remember this point. Engineering services same weightage for analog and digital, but in the gate exam, analog communication 40% means digital communication the weightage is 60%, but engineering services 50-50 weightage for both the points. Now the otherwise, I can say that total subject we can divide into three parts: analog communication, digital communication, and noise analysis. Because in the recent papers, more questions you will find from noise. Whatever be the competitive exam, it can be a gate or engineering services exam, or even it can be a ISRO exam. Whatever be the competitive exam, you'll find more questions nowadays on noise analysis also. So already I told you some of the students might have attended the AS Academy or any other institute. This time I'm going to solve more number of questions in the random signals, because that is the area where more students are not getting the confidence. But this time I have decided to solve as many questions as possible in the topic random signals and noise analysis. Whereas analog communication, very simple, very easily you can understand. The only clarity, more clarity required is on the topic random signal theory as well as noise analysis. Okay, uh, I will start the subject with 10 minutes break. Just break is only for 10 minutes. Now it is 12. Now 12:10. I will start at 12:10. With small break, I will continue the class. Please wait for 10 minutes.
Raju. Raju, line లో ఉన్నావా? Raju. 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 Raju.
హలో అన్నా.
వాయిస్ క్లియర్ ఉందా రాజు?
క్లియర్ అనే ఉంది.
సరే, మధ్యలో మధ్యలో ఒకసారి మెసేజ్లు ఏమైనా వస్తే డిలీట్ చేసేసి.
అదే చేస్తున్నా ఆల్రెడీ.
నేను మాక్సిమం మెసేజ్లు డిలీట్ చేసిన. అదే వాయిస్ క్లియర్ గానే ఉంది, ప్రాబ్లం ఏం లేదు. నీ వాయిస్
క్లియర్ గానే ఉంది.
నా వాయిస్ ఏమైనా బ్లర్ వస్తుందా?
ఏం రావట్లేదు.
పర్ఫెక్ట్ ఉంది కదా?
పర్ఫెక్ట్ ఉంది.
ఓకే, రైట్.
ఓకే.
Okay. Okay, my dear students, I'm starting unlock communications first. So still some, sorry. Okay, my dear students, Now I'm starting unlock communication systems. Some students still saying that the voice is not audible. We checked it already. Everything is perfect. Please check from your side. Is there any problem? If required, restart your system. Mobile phone, you restart and check it out. So we checked it and it is working perfectly. I hope that if the problem is there, please post in question and answers. I hope that now it is clear. Okay. Now, some students, instrumentation students especially asking when the syllabus will go over. Just now we started, it takes more time. So the major problem generally that I'm facing here is that syllabus is not same. But the point is that I cannot discuss only that portion of the syllabus first and remaining for the students last some 20 hours may not be required. The total subject will be around 80 hours. Please remember, it will be around 80 to 90 hours it takes. Only last 25 hours it may not be required for instrumentation students. And main the thing is that the if we are allotting some other subjects, some students are rising, we are writing some other public sector exams, then why are not allowing us to listen to this subject? See the problem, both sides of the students. Some students are writing only the gate exam. They are asking when the other subject will start. Already I didn't start, I started today only, but they are asking when the other subject will start. So please have patience and listen. If it is not, I will before one day itself, I will tell you this subject, this topic is not required. So please, in that time, have a revision. You go through the subject, you try to solve the problems whenever the topic is not there, and ask the doubts in the next session. So I will inform to you very well in advance, this topic today's session not required for instrumentation students. Like that I will inform. But the entire session, for the sake of some students, you are writing the other competitive exams. No other schedule till the completion of this subject for instrumentation students except last 20 hours during that period. But when you are allotting some other subject, what I'm saying that some students are rising, why you are not allowing us to listen? Because they are writing some other public sector exam. So instrumentation students, kindly cooperate. If the topic is not there, please utilize that time in preparing the subject, or try to solve as many questions as possible. That is what my sincere request to the students is. Okay, now coming to the subject. I told that I'm starting analog communications. Now, what is the definition of modulation with respect to time domain? In the introduction, I told you modulation definition always it is interpreted in two ways. Definition of modulation in frequency domain, definition of modulation in time domain. In frequency domain, if you remember, I gave you four definitions. Try to recollect. What is the first definition? Do you remember? First definition is process of converting low frequency signal into high frequency signal. Then what is the second definition? Try to recollect. Frequency translation. What is the meaning? Spectrum of the signal shifted from one region to another region, low frequency region to high frequency region. What is the third definition? Process of converting a low pass signal into a band pass signal. Fourth definition, process of converting a wide band signal into a narrow band signal. So these are the definitions which are applicable in frequency domain. Now I am giving what is the definition of modulation in time domain. Please listen. Look here carefully. How to define modulation with respect to time domain? That means I'm giving the definition of modulation. I will give you clearly many examples. Don't worry, carefully first understand the concept. Then modulation, how it is defined in time domain. Modulation is defined as the process in which a parameter of the carrier is varied according to the message signal. Modulation, it is defined as the process in which a parameter of the carrier is varied according to the message signal. Sometimes it is given according to the instantaneous value of the message signal. I will explain. This is the definition which is applicable in time domain. I will give you a full clarity on this. Now see here. I want to explain both the definitions by taking some example. Always I'm trying to give the concepts using the graphical methods. All of you listen carefully. First, try to understand. Listen. Assume that the message signal is exponentially decaying signal. This is the message signal. This signal I want to transmit from one place to another place. Now think carefully. Whenever you want to transmit the signal, first thing you have to check is what are the frequencies present in that electrical signal. How to determine the frequencies present in that electrical signal is you have to convert this time domain signal into frequency domain signal. You may be knowing what is the Fourier transform of e power minus t into u of t 1 by 1 plus j omega. This is the Fourier transform. Now, whenever a complex quantity is involved, j term is there, I want to sketch the magnitude spectrum. So, at f is equal to 0 or omega is equal to 0, what is the magnitude is equal to 1. So then what about the magnitude? As omega increases or f increases, magnitude gradually decreases, and when the magnitude becomes 0 is only at f is equal to infinite or omega is equal to infinite. So what is the magnitude spectrum? As f increases, magnitude gradually decreases and becomes 0 only at f is equal to infinite. Now, this is the magnitude spectrum of this exponentially decaying signal. Okay. Now, what is the important observation from this diagram? Now, look here. What is the important observation is signal. Is it having significant low frequencies or high frequencies? Please, all of you think carefully by observing the diagram. If you observe at high frequencies, what is the magnitude is almost zero. That means high frequencies are not at all significant. Only low frequencies are significant. Listen carefully. What I'm saying is only low frequencies are significant. Then what is the problem? Whenever the signal is having whenever the signal is having significant low frequencies, the size of the antenna required is very high. Listen carefully, size of the antenna required is very high. So how to overcome this problem? So remember, I am not in a position to transmit this signal directly into free space. The reason I'm telling is it is having significant low frequency. At high frequencies, what the magnitude is almost zero. Still, some students are posting that audio is not clear. Please give the feedback to me in questions and answer section. Repeatedly, I'm telling from my side, I checked no problem at all. Please, my dear students, please give the feedback on the question answer. Is it clear or not? I don't know why many of the students. So many students are saying it is clear. I don't know. Please, my dear students, please check your internet connection or your device. Many students are saying that there is no problem and it is audible. Some students only putting that message. Again, I'm requesting you to restart your mobile phone or check the audio settings. Please, my sincere advice is. Okay, I'm continuing. Now look here. Please, my dear students, look here. What I'm saying is that this signal, it is having significant low frequency components. So we are not in a position to transmit this signal directly into free space. How to overcome this problem at the transmitter side? How to overcome this problem at the transmitter side is by modulation. Already I told you clearly what is meant by modulation. Modulation means the signal should be multiplied with carrier. Carrier means already I told you it is a very high frequency sinusoidal signal. Okay. Now look here. This is the carrier signal multiplied with carrier. In the meantime, please think about what I'm going to explain. The message multiplied by carrier, that I'm calling it as the modulated signal. What is meant by modulation is message multiplied by carrier. not only this subject, any other subject also. First, you have a clear idea about the fundamental concepts. Then only you will be in a position to answer any question very easily. I told you to think in between whenever I'm writing. I told you clearly, whenever a signal multiplied with carrier, what happens to the spectrum? You know very well, spectrum of the signal will be shifted to the left side as well as to the right side. Carefully see what I'm sketching is. Where it is shifted to the right side means it is shifted to plus FC. And spectrum of the signal is shifted to the left side. Where it is shifted is equal to minus FC, and I told that amplitude becomes half. Now look here. Now think about the definition of modulation in frequency domain as well as time. First you think about frequency domain. See, low frequency signal now converted into high frequency signal. What is the second definition? Frequency translation. Spectrum of the signal shifted from low frequency region to high frequency region. But I want the analysis in time domain. How to interpret in time domain, that is more important for me than in frequency domain. Please look here. How to sketch the waveform? All of you listen. This is very important concept. Look here. Carrier cos 2 pi fct. Suppose if I write here 10 into cos 2 pi fct, can you think what 10 indicates? Carefully think what 10 indicates. 10 is nothing but the peak amplitude. Some students are saying amplitude, but that is not correct. It is the peak amplitude, because the amplitude of the sinusoidal signal, it is continuously it is changing. Amplitude varies from minus 10 to plus 10. So this 10 I can call it as the peak amplitude. But there is another name for the peak amplitude of the carrier in this subject. What is that another name for the peak amplitude of the carrier? It is also called as the envelope. Please remember this point. Many times we are using this terminology. So another name for the peak amplitude of the carrier is nothing but the envelope. Then in okay, sorry for the interruption. Sorry for the interruption. Now look here. Now, what I'm saying is that I want to interpret in time domain. Now the point is that, so see here, this is the carrier before modulation. What I'm saying is that the what is the envelope? Draw a line touching all peaks of the carrier. Now what I'm saying that if you draw a line touching all peaks of the carrier, what you are getting is a constant value of 10. So what is the envelope of the carrier is a constant value of 10. One thing is that sinusoidal signal, it takes both positive as well as negative values. So positive envelope is equal to 10 means, please think what is the other envelope. What is this other envelope is nothing but minus 10. Please listen carefully. Positive one envelope is plus 10 means other envelope should be minus 10. One envelope is plus 5 means other envelope should be minus 5. So what I'm saying is that so the same. Now see here. For convenience, I'm taking it as 1. Okay. There are some problems. Okay, I will conclude. So mostly tomorrow I will see that there will not be any problem. Many students are raising some problems, but please kindly cooperate for today. I will close in few minutes. Tomorrow I will say that you will not get any problem at all. So kindly cooperate for today. Okay, look here. Just with this topic, I'm going to conclude. Now see here. Now what I'm saying is that this is the carrier. Then what is the carrier after modulation? Or I want to know what is the modulated signal in time domain. This is the
Dear students, wait for 5 minutes. Dear students, wait for 5 minutes.
Okay, students, there is some problem with internet connectivity. I hope that it is clear. Kindly cooperate for today. Tomorrow there will not be any problem. Are you okay? I will conclude with this topic. Tomorrow I will resume. So is it okay for you? Are you able to hear or not? Please respond. Okay. Okay. Okay, my dear students. Now look here. Sorry, because a very important topic, many interruptions coming on this one. Now look here. What I told you that I took a exponentially decaying signal as the message. And I told you the signal is having significant low frequency components. So we are not in a position to transmit the signal directly into free space. Problem I am saying is size of the antenna required is very high. Now to overcome this problem, I took a very high frequency sinusoidal signal. And what is the envelope of the carrier before modulation is constant value of 10. Now what is meant by modulation? Modulation means message signal multiplied with carrier. What is that message signal I took is e power minus t multiplied. Now I want to sketch the waveform. Carefully think. It is nothing but the carrier only, but envelope is not constant. Envelope is exponentially decreasing. Please see the previous diagram. Envelope is 1. I told that sinusoidal signal, positive envelope is 1. What is the other envelope is minus 1. In the same manner, here also the sinusoidal signal, but what is the envelope? Carefully think about it. What I'm saying is, this is the positive envelope. Please think all of you carefully. What is the negative envelope? Negative envelope will be always symmetrical. I told that plus 5 minus 5, plus 1 minus 1, plus 2 minus 2, like that. What is this other envelope is minus of e power minus t. Please look here. Positive envelope is e power minus, this is minus of. Then what is the waveform? Please look here. It is nothing but the carrier only. It is nothing but the, see the waveform. This is the modulated signal in time domain, whereas this is the modulated signal in frequency domain. Frequency domain concept we are now thorough. Now think about time domain. So this is the what we are transmitting into free space is nothing but this modulated signal. Now think carefully, see this one. Again and again I'm saying, I considered exponentially decaying signal as the message, and we are not in a position to transmit the signal directly into free space. So I took a very high frequency sinusoidal signal. That high frequency sinusoidal signal, I'm calling it as the carrier. Please see the terminology. So that means that high frequency signal should carry this information. How that high frequency signal is carrying that information? Please the second one and third one. Second one represents the carrier before modulation. Third one diagram is nothing but the carrier after modulation. Carefully see this diagram. What we are transmitting is a very high frequency signal which is carrying that information in the form of amplitude. Please remember, what we are transmitting is a very high frequency signal, and that high frequency signal carries the information in the form of amplitude. So this is the example of amplitude modulation. See the definition. What I told is, modulation is defined as the process in which a parameter of the carrier is varied according to the message signal. In this example, which parameter of the carrier is varied according to the message signal is amplitude. So we are changing the amplitude of the carrier according to the message signal. That is why I'm calling this as amplitude modulation. So in AM or in amplitude modulation, that high frequency signal is carrying the information in the form of amplitude. Remember, repeatedly I'm telling. So this is what the definition of modulation in time domain. Whereas in frequency domain, low frequency to high frequency, or the spectrum is shifted from low frequency region to high frequency region. Like that we are interpreting. So repeatedly I'm telling, we are transmitting a very high frequency signal, and that high frequency signal should carry that information. Now, what is the generalized equation of the carrier? Just I am giving the conclusions. What is the generalized equation of the carrier is AC cos 2 pi FCT plus phi. What are the three parameters of the carrier? Are amplitude, frequency, and phase. In the previous example, which parameter of the carrier uh, I varied is amplitude. So the whenever you change the amplitude of the carrier according to the message signal, then I'm calling it as amplitude modulation. It is possible to change the frequency of the carrier according to the message signal. Then we are calling it as frequency modulation and phase modulation. Later, these two together called as angle modulation techniques. Later, I will tell you why these are called as angle modulation techniques. So basically, three methods: AM, FM, and PM. So analog communication is considered classified into three types: amplitude modulation, frequency modulation, and phase modulation. In AM, high frequency signal carries the information in the form of amplitude. In FM, high frequency signal carries the information in the form of frequency, whereas in PM, high frequency signal carries the information in the form of phase. So these are the three fundamental techniques of analog communication is concerned. So uh, today's class I'm concluding with this. Just listen first. So in today's class, what I have explained is, first I have explained you the generalized block diagram of the communication system is considered. Next, I explained you what is the need for modulation. I have given you 6 points why modulation is required. Again, all of you go through those 6 points again and have the clarity about those points. Any doubts also, please get it clarified in tomorrow's class. And then I explained you what are the notations as well as terminology. Then what is the concept of modulation as well as demodulation. Finally, I told you about the introduction to the all the three modulation techniques are considered. Now I'm attending your doubts are considered. Hello, Mr. Sai Siva. Sai Siva. Hello, Mr. Sai Siva. Are you able to hear me? Soumya, first unmute your system. Soumya. Soumya, are you able to hear me? Signal. అది రైజ్ హ్యాండ్ ఎందుకు లేదు అనేది అర్థం కాలే. మళ్ళీ వన్స్ అగైన్ చూడు ఎందుకు రావట్లేదు. హలో మిస్టర్ మధు.
Sir, good morning, sir.
Good morning. Tell me.
Sir, can I know what is meant by an band unlimited signal, sir? So in certain times we call the signal is not band limited. Like
I
mod.
never heard the word. We are using the word always band limited. There is no word like that, band unlimited. So signal that I don't know where you have come across. Can you tell me the textbook name? If it is some material, I will not at all consider. So why I'm saying is that please see the concept. I told you, see this diagram which is available on the screen. So this is a signal is having frequency components up to infinite. By using a low pass filter, I'm uh, limiting the signal. Now the signal is band limited to 1 by T. That means I'm eliminating the frequencies above 1 by T. Band limited concept is applicable only to low pass signals. Again, I'm saying it is not at all applicable to band pass signals. It is applicable only for low pass, not at all applicable. So theoretically, it is having frequency components up to infinite, but by using a low pass filter, I'm eliminating the insignificant frequencies. What is the cutoff frequency? It is 1 by T. Let us assume that if the cutoff frequency is 10 kilohertz, that means I'm band limiting the signal to 10. Signal is band limited. Band unlimited, there is no such term generally will come across. I never come across the terminology in my life. Really, I'm
Sir,
saying.
in finding the sampling frequency of mod scientists, they have given that it is
Please don't ask the questions which I have not started. Sampling, we are going to discuss later.
okay, sir. Thank you, sir.
I will discuss sampling in digital communication. Don't worry about it.
Okay, thank you, sir.
Okay. Hello, Subhi Jain. Subhi Jain, please unmute your system and talk to me.
Hello.
Please unmute.
Hello.
Yes. Yes, madam. Yes, madam. I'm able to hear.
Sir, yes, sir. What is the difference between, sir, voice and audio, sir? I didn't get that.
Voice means only human voice, madam. Our voice, human being. What is the voice? Will be in the range of 300 to 3.5. Audio means any sound that you suppose take a musical instrument like a guitar. You are able to hear that sound, but is it my voice? It is not
Okay,
voice.
okay.
So any sound that I am able to hear is nothing but audio. Suppose you are listening to radio. Radio means it includes voice, music, or any other sound. So remember, audio means any sound that we are able to hear is called as audio. So our ear is sensitive to 20 hertz to those are the only frequencies we are able. In this free space, actually, there are so many frequencies, but why are not able to hear? Because they are not in the audio range. That is what the thing. So,
Okay.
that's okay.
Okay, sir.
Thank you,
Thank
madam.
you, sir.
Thank you, madam. Unmute, please. Hello, Mr. Roshan Agarwal.
Hello, good afternoon, sir.
Yes, good afternoon, sir. Yes,
Sir, I
tell me.
had a query in that, sir, that at last part you told envelope, no, sir? Can you open that?
Yes, sir. I remember. Yes, tell me.
Sir, I had a query means like that envelope we have took as one, the magnitude, the peak amplitude, but
Yes,
sir,
peak amplitude.
the modulated signal which we are getting, in that the envelope is e to the power minus t and minus e to the power minus t, no, sir? How?
Sinusoidal signal. Suppose if I write, see here. Suppose I am writing 10 cos 2 pi fct. Look here. What will be
Yes.
the waveform? Please look here. This is a sinusoidal signal. Can you tell me what is the
Yes, sir.
positive envelope and what is the negative envelope?
Yes, sir, plus 10 and
Positive
minus 10,
envelope
sir.
is plus 10 negative. So sinusoidal signal always takes positive values as well as negative values. So if this
Yes, sir.
envelope is plus 10, but the other envelope should be minus 10. If it is plus 5, it should be minus 5. In the same way, that is why I have written it is e power minus t. Other side, it should be minus of e power minus t. That is the reason for writing like that.
Oh, okay, sir. Okay. Yes, sir. Yes, sir.
Okay.
Okay.
Thank you.
Okay, sir. Got it. Thank you, sir. Thank you, sir.
Jahnavi.
Good afternoon, sir.
Good afternoon. Please tell me what is your doubt.
Sir, in the oscillator, we are using a Hartley or Colpitts. Why don't we use RC phase shift oscillator?
So at high frequencies, there are certain restrictions. Analog circuits will tell you about those restrictions about oscillators, amplifiers always depends upon the frequencies, but the design of the amplifier at low frequencies, design of the oscillator at high frequencies. So there are certain problems. So that sir will be discussing. There are so many parameters about that coupling capacitance, or many parameters are there. So sir will discuss about analog circuits. Sir will tell about what you are using as a carrier is, how to generate the carrier is. Most of the cases you are using either Hartley oscillator or Colpitt's oscillator. So sir will discuss about those constraints are considered.
Okay, sir. Thank you, sir.
Manikanta.
Hello, good afternoon, sir.
Yes, good afternoon, Manikanta. Please.
Sir, in this case, cos 2 pi ft signal is passing through origin, sir. Cos signal is not passing through origin, sir.
Where it is passing through origin? Can you tell me where? Where,
Sir,
sir?
in second row, sir.
Second?
24F, 24F.
24F. So that means what you mean to say that okay, at T is equal to J, is not at all a problem, sir. In our subject, cos and sin, no problem. That I will explain tomorrow's class.
Sir, and information can measured in only time domain, sir, but not in frequency domain. How, sir?
I never use that word information measured only in time domain. How we are saying that?
Here, sir, information is measured by the carrier signal according to vary with the message signal, sir.
That means what is the message signal? I'm talking on a telephone. That is, my voice is a random signal. But instead of taking a random signal, what I took is only exponentially decaying signal, so that very easily can understand.
Okay, sir. Thank you, sir.
Carrier always carries the high frequency signal, should carry that information. But what is that information? Only for convenience, I took it as exponentially decaying, but most of the practical signals are random signals. That voltage will be changing randomly. According to that, amplitude of the carrier also changes accordingly. Whatever be the variations of the message, same variations should be reflected in the amplitude of the carrier in time domain. In frequency domain, analysis is very, very simple. Shift the spectrum is shifted to plus FC as well as to, that is what the problem. How to analyze modulation in time domain, how to analyze modulation in frequency domain, completely different ways. That is what the students are getting confused. Please remember, analysis in frequency domain is different, analysis in time domain is different. That is the problem. Okay. 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 Hello, Sai, Khati, Sai.
Hello, sir.
Yes, I'm able to hear. Tell me.
Sir, in cos 2 pi fct, what does T indicate, sir?
It is changing with respect to time. Signal is changing. What is the FC is constant. 2 pi everything. What is the variable parameter in that cos 2 pi fct? Tell me T. So the signal is changing with respect to time. That's all. 2 pi constant. FC
okay.
also some carrier frequency, some 1 megahertz, 10 megahertz like that. Only variable parameter is T here, there. That's all.
Okay, sir.
Hello, Mr. Samir.
Hello, sir.
Yes, tell me, Samir. Samir or Satyam?
Satyam, sir. Sir,
Satyam,
can you tell
okay.
me
Yes, I'm
difference about spectrum and frequency?
What, sir?
Spectrum and frequency difference.
Spectrum is nothing but a set of all frequencies present in the signal.
Okay, sir.
What are the frequencies present? Sinusoidal signal spectrum consists of only spectrum indicates frequencies present in a signal. Suppose take a sinusoidal signal. How many frequencies are present in a sinusoidal? Means only one frequency. Suppose here carrier. So this is the spectrum. How many frequencies carrier is having? Means only one frequency. Suppose if we take this signal message, how many frequencies message is having? Spectrum always indicates the frequencies present in a signal. Here, what are the frequencies present? 0 to W. So signal is not having one frequency, it is having multiple frequencies. Frequencies are 0 to W. Suppose if we take the sinusoidal signal, how many frequencies spectrum is having? Spectrum is having only one. So spectrum indicates the frequencies present in a signal. That is what the difference is.
Sir, during taking Fourier transform,
Hmm.
hello, sir.
Just tell me.
You transform it in spectrum, not frequency now. It's a spectrum. You drawn the figure in a spectrum band of frequency, no, sir. Not only particular frequency now.
So it is once you sketch the spectrum, you will know is it only one frequency or is it a band of frequency. Suppose carrier is having only one frequency. Suppose you take earlier, I told you that spectrum in this case it is having only some the triangular inset of frequencies like that. So it is a spectrum. What is the parameter I took along x-axis is frequency. Variable parameter is frequency.
Okay, sir. And sir, one more doubt, sir. Sir, you told that xf and x omega, is there a difference? I don't get the point. Is there any difference or both are same, sir?
Only
xf
thing
and
that angular frequency, what is omega? Omega is equal to 2 pi f.
angular frequency, sir. I think you
Radians per
told that
second, but frequencies means you are expressing in hertz. But omega means you are expressing in radians per second.
sir, you told like some book represent in this manner, some book represent in this manner.
Oh, but nowadays communication means whatever be the competitive exam, frequencies will not be given in radians per second. Take gate engineering services, the signal having a frequency of 1 kilohertz is transmitted. They never say that signal having a frequency of some 10 radians per second. So communication means frequency always you are talking in hertz, not in radians per second. Generally in signals and systems, sometimes you are using omega notation, but in communication subject, we never use omega notation. That is what I told. Always you are using frequencies means expressed in hertz, not in radians in communication. But in signals and systems, sometimes you are using radians also, radians per second. That
Okay,
is
sir.
what I told actually.
Sir, one last doubt, sir. Sir, you earlier already cleared that, but I don't get the point, sir. If the envelope during last discussion class envelope is minus e to the power minus t, and during after modulating it with sinusoidal signal, it's come over up and down both side, but modulating signal e to the power minus t is only on upper side. I don't get the how it convert download downside also. I don't get the point.
Suppose signal is 10. Look here. 10 means we are getting only on the positive side. Okay, is it or not?
Yes, sir.
Now tell me how to draw the waveform 10 into cos 2 pi fct.
Sinusoidally vary with amplitude of 10.
Then positive side plus 10, negative side minus 10, is it or not?
Yes, sir.
Then that is what I am asking that out is. Okay.
Thank you, sir.
Thank you. Hello, Mr. Samir.
Hello, sir. Good afternoon, sir.
Good afternoon, Samir.
Sir, you told that sinusoidal signal have only single frequency and other waveform have multiple frequency. But sir, how
Yes.
sir means the triangular and
Fourier
square wave, sir,
transform.
if we take.
What is the Fourier transform of cos? Fourier transform of cos, already told you, AC cos, this one. See the rectangular pulse. How many? See this slide. So the what I have shown, rectangular pulse having 1 millisecond. See the diagram and tell me how many frequencies it is having. 0 to 1 kilohertz.
Yes, sir.
So rectangle like that. Fourier transform. With the help of Fourier transform only we are able to determine how many frequencies are present. That is what I told. What is the Fourier transform of cos? Fourier transform of cos, what I told is, look here.
Half of delta of f minus
Delta of f minus f. Yes, what you are saying is exactly correct. So delta means what is the function? Function. Look here, just one point. See this one, cos 2 pi fct. So delta of that means impulse function located at fc means how many frequencies it is having is only one frequency. That's all.
And sir, I have another doubt, sir.
Just tell me.
Sir, if we take a square wave and we can find the frequency by reciprocal of the time period. and we will get a single frequency. But when we Fourier transform that the rect function, we are getting multiple frequencies. Like you told that 0 to 1 megahertz.
Where
So
I
how
told
to
you,
extract?
where I told that it is only one frequency. That is what I told. Rectangular function. See that one. That is what I told you. See the rectangular function. Is it having one frequency? Tell me.
No, sir. If we
0
find
to
the
1
frequency
kilohertz. Bandwidth is
by
1 by t. Bandwidth is 1 by t.
okay.
Bandwidth
But
means
sir,
highest frequency minus low. What is the highest frequency occupied is 1 kilohertz. Lowest frequency
1
occupied is 0. Bandwidth is 1 by t. I never told that it is having only one frequency. Rectangular pulse is having many frequencies. In this case, pulse width 1 millisecond means it is having frequencies from 0 to 1 kilohertz. Pulse width is 1 microsecond means it is having frequencies from 0 to 1 megahertz.
but sir, always we told that frequency is reciprocal of time period, sir.
Reciprocal of that is for periodic signal. Here I am not at all talking about periodic. It is a only one pulse I took. It is a non-periodic signal. Impulse function, is it periodic or non-periodic? There is no time period concept here. I'm not at all talking about periodic signals now. I'm talking only about non-periodic signals. When you talk about the periodic, then only the time period, what is the fundamental frequency, not frequency. Fundamental frequency f naught is equal to 1 by t naught. Tomorrow I will clarify that doubt. Don't worry. What you have asked is a good doubt. Tomorrow I will deal with periodic signals. Okay. I will clarify your doubt tomorrow about periodic.
Okay, thank you, sir.
Thank you. Mr. Sriram. Mr. Sriram.
Sir.
Yes.
Sir, you have said that message signal are usually low frequency signal and carrier signal should be a high frequency signal.
Yes.
Is there any limitation that the message signal should be some in particular this range or any
That is what I told.
limits?
Our voice is in that range. It is, we cannot say that God has given our voice in the range 300 to 3.5. What I'm saying, that audio means 20 hertz to 20 kilohertz. That we cannot change. It is by nature. Suppose I'm hitting on the table now. See, you are able to hear the table sound. What is that frequency of that signal? I'm hitting some metal. What is the sound it is produced? So that we can't change. That is by property, by nature. This is the properties. Whatever is there, that we cannot change. Audio means it is 20 hertz to 20. Our human ear can hear only 20. But if you see, maybe knowing. Suppose if you take the animal dog, hearing range is different. So that is we cannot change. So that is voice means in the range 300 to 3.5. By once you talk on see the spectrum analyzer, it will display that signal. So that is by property of voice signal, we cannot change at all. So that is by nature. That is most of the practical message signals we are talking, voice, audio, video, all these signals are having significant low frequencies that we are not changing. That is by nature itself, those are low frequency signals. That's all.
Okay, sir. Got it, sir. Thank you, sir.
Okay. Okay. Thank you. Please think about the topics what I have explained today's class. Please have a clear idea. Definitely tomorrow I will take more time to attend your doubts. I'm giving you some time to think about. Some of the students may be fresh means they are attending the classes, coaching class for the first time. But once again, what my sincere advice is, today's class you go through once or twice. Please have a clear idea about the fundamental concepts are considered. So we'll continue tomorrow at 8 a.m. Schedule is always 8 a.m. So tomorrow we'll continue.